Hi, jury members, those of you here with us today in the room, and all of you joining us online. Welcome to the Multifamily Housing Division. India is seeing a surge in apartment construction. Imagine the incredible energy and water savings we could achieve if the homes were designed to be net zero. Mastering this field presents a huge opportunity for future professionals. The team in this division have developed some amazing ideas. I can't wait for you to see them all. I'm excited to welcome you all for the presentations of the Multifamily Housing Division to see what the teams have come up with. My name is Sanchi Pathela and I will be the MC for today. It's my job to keep us on time and I will be taking it very seriously. Our finalist teams have put in a lot of hard work. They have submitted their project reports about a month ago. And these teams will present their work to the jury. Teams, you will have 20 minutes for your presentation, followed by a 10 minutes Q&A session. There will be a 5 minutes break after that. You must use your 5 minutes to take your component model out of the room and allow the next team to bring their model in. The Multifamily Housing Division has 3 jury members who have expertise in net zero and resilient design. We have Sean Sengupta, Director and Head, North Edifice Consultants Private Limited. Hi, Sean.
Hello. Hi.
Next, we have Alok Deshmukh, co-founder and MD, Superhuman Race Private Limited. Hi, Alok. Our third jury member is Yash Sangvi, Head of IoT Practice, Atomberg Technologies Private Limited. Hello, Yash. These jury members have had 3 weeks to review the reports submitted by the teams. They have looked at your work in detail and have already assessed your entries for the 10 contests of Decathlon. Teams, your presentation will help them hear your narrative. They will assess your presentation and your mastery over your solution through the Q&A session. They may revise their scores based on what they hear from you today. Jury members, I'm so excited to have you meet the teams today. I will need to interrupt you all also to help us stay on time. Please don't mind. I'm looking for your support on this. Please keep your comments and questions short and to the point. All right, ready to begin? Let's start with the presentations. Our first presentation is from Team Sanctum. They have worked on a project by Godrej and is located in Gurgaon, Delhi. Answers direct and to the point. All right, team, the stage is yours.
Good morning, everyone. We are representing Team Sanctum from Balwant Sheth School of Architecture and Mukesh Patel School of Technology, Engineering and Management. We have a project partner who's Godrej Properties Limited. I'm Ridhima, this is Aaron, this is Anushka, and this is Jeppa.
Sorry. It's not on. It's on PPT mode. Okay. Yeah. So our site is located in Sector 54, Gurgaon, within the NCR region. And our initial approach was to study the immediate context. So we're looking at the type of neighborhoods around, what people need in those neighborhoods, what is their quality of life currently, the commercial developments, residential developments. And we understood that the project's brief by the partner was a luxury residential development. They had given us a certain formula to follow for the parking as well, which needed about 500 cars to be accommodated. And we studied the market to understand the market demand as well as the user demands, their needs, their wants of the homes. And we understood that most of them prefer a 3 and a 4 BHK type of houses. Further, we looked at the site, and the plot area is about 11,000 square meters. The total built-up area is about 40,000 square meters on the same, which is permissible with an FSI. And we were required to keep only 40% of it could be built, and a minimum 40% had to be landscaped or green. Further, the site had an irregular shape, which wouldn't have been a problem, except that we had a 16-meter setback, which we had to follow at the minimum. So that left only the part marked in red buildable. Further, we were also asked, if possible, to orient some amount of these houses towards the southwest, where we had the Aravalli mountain range, which added a premium on the saleability of the homes. And then moving to the climate study, the main climate is a composite climate over there. What we understood through our climate study and our pre-design is that we need to sort of allow heat ingress in winters and allow heat loss during the summers. And so we would optimize the sun for this, optimize orientation and massing for the same. Along with that, even the majority of the wind is from the northwest and the southeast. And we've been looking at which parts fall within the IMAC comfort range, which we will discuss further in the facading as well. What parts, which becomes our target sort of climate range, which is going beyond this comfort zone.
We further divided ourselves into contest areas based on each person's technical know-how. We also collaborated with industry specialists, like, for example, iSpace, who helped us with our cost estimation and market rates, while Professor Chetan Tolia helped us review our structural grids.
Okay, so moving on to design, we had certain key ideas which we started with. For example, the orientation, optimization of the core, optimization of the site, so that it creates distributed structures to balance the built and the unbuilt. And also, the main conceptual approach was to redefine luxury in a way where it's not limited to only materiality, but also through luxury through nature in that sense. So creating these green spaces, because we were anyways required to maintain it, so enhance that in that sense. And we had our visits to site, we discussed the same with the project partner, and exploring various forms of massing until we reached, we tried an idea which needed 3 towers, which allowed self-shading and to some extent, but also allowed heat gain in winters and heat loss in summers. And understanding which sort of massing was working in terms of display of heights and rotation to enhance the same effect and allow privacy between the units as well. And ultimately discussing the same with the project partner to understand how we can create these hierarchical green spaces and reach a final massing, which was something like this. And so our master plan sort of translates into this from our initial ideas. And also at a cluster level, where we start exploring these hierarchical green spaces at the unit level through balconies and open spaces, at a common or a cluster level through common terraces which are shared, at a site level through a richly landscaped podium and a ground level, and even at a unit level where we start looking at the amount of usable daylight which is there, where about 86% of the floor receives more than 83% of useful daylight. And looking at the salient features of design to allow serviceability for ease, because it's a luxury apartment, the project partner has certain requirements in terms of service access or access of ducts even. So looking at the salient features of the homes, and that's how design translated.
As we move on to engineering and operations, we basically divided into 3 subcategories. It was HVAC when it came to a unit, it was HVAC when it came to shared and amenity spaces, and it was waste management, which we looked at. So when we talk about HVAC at a unit level, we preferred to use a VRF system over a split AC system. Obviously, because we know Gurgaon has a composite climate, it requires both heating and cooling, and a VRF system is able to do that more efficiently rather than having a split AC and a heater separately installed. There is also more benefits of the VRF system, as it is more energy efficient, it is more space efficient, and it also has a reduced running cost as compared to split AC use. Based on the IMAC comfort range and calculations further from that, we were able to also understand that we would only need to use VRF for only about 180 days where the temperature ranges were falling under the uncomfortable range. Otherwise, we didn't plan to use the VRF system. On the plans, you can see there are areas marked. Those are areas where we are having the outdoor units placed for each household. So each household is given about 1 unit, and they are kept in spaces which are easily accessible even for maintenance. As we go ahead, we looked at how HVAC can be handled in terms of amenity spaces. So in terms of amenity spaces, we decided to use geothermal cooling. Now, the reason why we did this was that geothermal cooling, when compared with centralized cooling, was proving to be much cheaper as an operational cost. And it was also able to service all of the amenity spaces in a smaller sort of area. So it was becoming more space efficient in that sense. When we come down to waste management, we saw it in two ways. One was at the household unit level, where we first decided that we'll have a 2-bin system, which has wet and dry waste, and further down it would get segregated into e-waste, inorganic, and organic waste. We decided to have the inorganic waste also get further divided into food waste and used cooking oils, because used cooking oils, as per a market study, we were able to understand that we were able to generate 2 lakh rupees as a profit by just selling used cooking oil over a year. And the food waste which was generated was also going to our biogas plant, which is generating electricity for us. When we come down to waste management, we didn't only want to look at how waste is being handled at a unit level. We also wanted to look at how it's being handled throughout the construction phase and the construction process. So in our master plan, we tried to allocate at least different zones where we see that waste can be stored, collected, and then taken out to different, whether that be local vendors or wherever we want to sell it off to. Then comes health and well-being. In health and well-being, we tried to look at 2 aspects. The first aspect was our facade, because that was able to interact with each one of our units. And the second aspect was our landscaping. So in terms of facade, we first tried to understand what all factors are we looking at. Factors like orientation, the views which the project partner wanted, even maintenance cost, because we already know that Gurgaon has a high AQI, which means since there is a lot of dust and a lot of pollution which is happening, glass facades require regular cleaning, and that creates problems when it comes to safety. We also studied for each one of our building layouts all the 4 different facades which are being created, and the projection sort of lengths which we would require to attain in such a way that the summer heat is not entering the house, but the winter heat is entering the place. Some of these lengths obviously were undesirable because they were too much of a projection, so we have inculcated them with a significant deduction based on practicality of the. When we see our balcony detail, we have done 3 major steps to control how wind is going to enter in our houses. So the first step is the terracotta jali, which we can see here in the 3D model as well. What this jali is doing is, the way it is shaped, it's enabling the Venturi effect to occur. So wind is sort of flowing through it. And right in front of it, we have placed planters. And these planters are able to sort of help absorb whatever hotter of the air which is coming into the place. We also have added mist sprays towards the upper level, so in case watering needs to be done. And we are also looking to integrate this with a BMS system.
In terms of the second part of health and well-being, we've looked at landscaping. So at the site level, a few things we kept in mind was prioritizing biodiversity and planting native plants. We've used a green edge and a dense urban, almost like an urban forest plantation in the in the pocket which is unbuildable, and in the middle of that we've created a community space. The pathways are all porous pavers to increase site porosity. On the podium level, landscaping is designed based on the different programs, so each area is tailored to the program, and the edge is also designed using bamboo, specific plants for specific needs. Bamboo to reduce noise, which will be because of the metro which is next to the site. Yeah, when it comes to the other podium levels in which the parking is placed, there is a green facade almost using creepers, which serves two functions. One is the buildings around don't have to look directly into the parking. They have a green blocking to create privacy. And the second use is it absorbs any carbon emissions from the cars in the parking. And using all the landscaping, overall, we've created a temperature difference between the city entering the complex and into the site.
When it comes to energy performance, we divided it into two subcategories, which was energy consumption reduction and energy generation. So when we talk about energy consumption reduction, first we saw a base case model, which was having an EPI of 144. Obviously, this was the first model built, so there were all live faces. Further on, as we proceeded with all our design changes and all our design orientations and all those changes, our EPI continuously kept on dropping. We adjusted our lighting schedules, our HVAC schedules, even the types of windows and the types of materials which are used for the facading. And eventually we were able to reach and we were able to achieve an EPI of 29.4. And the total site consumption of energy also, which we were able to calculate, was about 20 lakhs for a year. When we come down to energy generation, we have 7 main categories of how we are trying to generate energy on site. The first is the kinetic road technology, which is actually present on all of our driveways. Next is the regenerative lift drive, which is present in all 3 cores of the buildings. Then we have BIPV walls for all the dead walls, which are still present on site. We have micro wind turbines for each and every refuge floor which we have, and they are oriented based on the wind directions. We have a biogas plant which is located on site. We also have eco gym. So what we do in the eco gym is we have specific machines which are helping generate and store electricity as they are being used. And we have solar PVs which are present on the terraces of all 3 towers, and also solar water heaters to cater for each of the towers. Overall, if we see all our energy generation technologies are giving us 26 lakh of energy per year, whereas we are only consuming 20 lakhs per year. So the remaining 5 lakhs, what we are doing is we are selling it back to the grid at the rate of 3.11 found from relevant documents, and we were able to generate a 16 lakh income from energy. Other than that, we also have an energy dashboard which we intend to have. So it's like a website which we are also planning to integrate with the BMS system in the future.
For water, we are looking at reducing, recycling, reusing, and repurposing water. 41% of the water is reduced annually. The grey water is treated by STPs and alum dosing technology. This water then goes into the hydroponic plants, the flower beds, and for flushing. Recycled water and the black water is used for irrigation. Sludge from that, as well as the food waste, then goes into biogas, which also produces energy. For embodied carbon, we're looking at 3 ways of reducing embodied carbon. One was we chose podium parking instead of basement parking. A 3-level basement parking was given to us by the project partner, but we looked at it into a podium parking because it reduces the excavation cost, the fuel, as well as it is naturally ventilated. Other things that we looked at for embodied carbon was using low carbon glass like Adhyay and sugarcrete blocks.
In terms of resilience, what we did is the strategies were incorporated based on different contest areas, and then were categorized into mitigation, response, recovery, and comfort. On each level, they manifest as different strategies. So for example, you have decontamination zones or sanitation zones that can be present on the ground floor, which would help, in case of a pandemic in the future. We have the green buffer, which is incorporated with the landscaping. And we have, in terms of earthquakes, we have base isolators and moment-resisting frames. On the podium level, there are, On the podium level, we have incorporated water features. evaporative cooling, and fire truck accessibility. Since it's a podium level, the ramp extends to the podium level as well. In terms of autonomy, the calculations were used for us to check how efficient our strategies are in terms of, in the future. And we also created a future projection specifically for heat waves, considering it's Gurgaon, that by 2040, when the temperature increases, we're able to offset the temperature by 16% and bring it back to what the temperature is currently. In terms of affordability, one of the things we did is for construction, we've used Maiwan and Sugarcrete blocks, which are to decrease the capital that we're putting in. And the second thing is, since it's a luxury project, a lot of the fittings and materials that we are using for finishes are more on the higher end, but we're investing in that initial capital so that over time, it pays along in the OPEX, especially for different machinery that we're using, and also because the fixtures get affected by hard water. Yes, so our overall breakaway average is achieved in 7.6 years. The life cycle cost decreases by 78.8% after 25 years. And over time, the profits manage to subsidize the maintenance costs. Sorry.
Another feature which we're looking at in terms of value proposition was increasing the saleability for the developer. So to use additional incentive for them to be motivated towards this project. So we're looking at it from the developer side as well as the user side. So on the developer side, what we have done is within a similar built-up area, we've been able to create more saleable area. We have done this by reducing passageways, dead spaces, confining the sizes of lobbies, and bringing things more within the FSI, or bringing them free of FSI in that sense, and so increasing saleable area. And by doing so, we've been able to create 23 more additional saleable units. And after discussing with the project partner, we estimate that a net profit about 118 crores can be expected from these units. Further to this, we've also been able to create more amenity spaces by this podium, where we have a large landscape podium, etc. A lot of these spaces become added as saleable factors for amenity, so it increases the saleability of the units further, and also an overall decrease of 13.9% in the overall capital expenditure needed for the construction of the same project. And while at the user side, we have been able to create a well-designed unit, which has access to open space, has access to ventilation, natural light, and a view as well of the Aravalli mountain range. We've also been able to create a richly landscaped podium, which is catering to various age groups, where there are spaces for the elderly, spaces for children, spaces for middle-aged people, and people in different walks and different uses of the site. Further to this, we've also been able to create spaces for delivery agents, people like that, who are temporary users of the site. And these amenities also add up, increasing the saleability of the house in the design of the clubhouse and places like that. And ultimately, what we've been able to achieve is about a 29.5 EPI, a 78% reduction in embodied carbon as compared to the base case, a 20% generation of energy in excess, which is effectively net positive. We also have a 41% reduction in water demand as compared to the base case, a 90% recycling of water, which is happening on side of grey water and black water, a green cover of about 42% on ground, and rupees 2.2 lakhs generated from the waste from the used cooking oil sale, a cost estimate of 79% reduction in life cycle cost, and a net profit of rupees 118 crores. And effectively, this is what we started imagining the neighborhood to be, where it's catering to these various age groups, catering to various people. And we redefine luxury to be more than just the materiality, where it becomes experienced more through nature and through these open spaces, which are being lost in this city. And that's our sanctuary. Yeah, that's it. Thank you.
Thank you, team. You finished well in time. Let's hear the jury comments and take questions from them. Sean, I'll start with you.
Hi, congratulations, and very well presented and within the time. So second, congratulations for that. One question I had is that, for the air conditioning of the spaces, you have suggested VRV units. And as you have mentioned in your layout, you have individual spaces allocated for each apartment, which is logical because, you can't have a common system for a residential like this. However, you have also said that you are looking at geothermal for the cooling system. How are you integrating geothermal output into these individual VRV unit systems?
Okay, so the geothermal cooling system is only being used for the amenity and the shared spaces currently. So we have kept the VRF system only for the units, and we have used geothermal only for the amenity and shared spaces like the clubhouses, the swimming pool washrooms, the lockers, all of those spaces.
Okay, thank you.
Yash, your turn now.
Okay. Very nicely done. I see, you have presented a lot of elements that you would like to call as innovation as compared to the base case. You have geothermal system, Venturi Jalis, mist sprays, kinetic road, regenerative lift drive, BIPV units, wind turbines, biogas, ecogym, sugarcrete blocks instead of AAC, and base isolators. My question is, out of all of these, which do you credit to be like the most innovative element?
Obviously, giving credit only to one would not go well. Technologies, and we have also tried to use different innovative materials as a whole. If we numbers, we are able to generate the most energy out of kinetic road drive technology, where as the car moves all Gurgaon is very heavy in terms of traffic, and even topic of energy generation. When we talk about energy reduction, using the sugarcrete block was the most beneficial because the sugarcrete had a very low U value compared to the AAC block. The sugarcrete block only had a U value of 0.2.
Okay, so since you have, just one follow-up question. Since you have pointed out kinetic road technology and sugarcrete blocks, how have you validated the feasibility and the effectiveness of both of these? So validation can happen in three ways. One, you actually build a proto and validate it. Two, you see someone else who has already implemented the system. Or three, you come across some literature that proves your point. So what have you used in this?
Most of the innovation, products that we have done is we've made sure that there is an active sellable product for that innovation that we are proposing. So we are saying kinetic drives, it has to be existent on the market and saleable. And actually, one of the things we did wonder about is, since it's not very common, it might be imported. If is it located in that, is it sold in Gurgaon itself? And our justification for some of them was whether, if it's a luxury project, can we accommodate that or not? So we have adjusted in that sense for kinetic road drives. They are not local. So in that case, we've considered it to be imported. So there's a product for that that exists.
Any product name or company
Yeah,
name?
there's a product name. We'll get back to you.
Sure.
In terms of sugarcrete, I would like to say that sugarcrete blocks are, so basically what we were also looking at in terms of sugarcrete was the joinery. So these blocks do not, there are different ways of which these blocks are joined, So that was something that was interesting. Another thing is we found that sugarcrete blocks, so the people who are producing this sugarcrete or have started with, having these modules made are in Delhi. So our embodied carbon in terms of our travel distance would also not be a lot, which is why we were going ahead with sugarcrete.
But you have seen anyone using sugarcrete in construction?
So basically, chemical system technologies in Delhi have started using sugarcrete for low-rise constructions for now, where they have started using them for walls as well as roofs or slabs. But for high-rise, we're not really sure.
We had also discussed the same with the project partner. We'd given them a few options of these materials. And they had asked us, since majority of the load was being taken by shear walls and the frame, the infill walls, they were flexible too. So by collaborating with them in that sense, they were open to this idea of using sugarcrete as well.
Got it. Thank you.
Thank you.
Over to you, Alok.
Yeah, so congratulations on getting here. Who did you work with at Godrej Properties? Okay. Okay. All right. Yeah, no, I echo what Yash said. You know, I feel like one question that came to my mind was, is there anything you did not do in your project? And I think, I mean, it's really enterprising in terms of, you know, you know, kya kuch nahi kiya hai, you know? So, and I think that's great. But you know, I have some questions around like some of the statements that you made, like you said, you've done the massing and the towers to allow heat gain in the winter and allow heat loss in the summer. And what's the evidence or the estimation for that?
So when we were discussing the massing, we had three major iterations. One was a singular mass, which was oriented east and west. One was the 2 towers, and one was 3 towers. And we had run incident radiation on all of them using Ladybug. But so if you look at it purely through incident radiation, the center 2 towers are also working relatively well. But if you are bringing into when we were bringing in factors like the built-up area, the setbacks which were needed, because when I said 16-meter setback, that's the minimum needed for just the podium area, and then it sort of steps in further as you go higher. So in that case, the other examples are becoming unbuildable. So if we're looking at the massing purely in terms of evidence, we're looking at incident radiation. But when you take into the actual factors of, say, built-up area, setback, things like that, then that's how iteration 3 became the most preferable, because it was 2 units to 1 core.
So what was the relative benefit of iteration 3 in terms of winter heat gain and summer heat loss? And you don't have to know the numbers, but like, did you see a tangible, real numerical benefit in comparison? Because I'm always, and as future professionals in the space, I think one just needs to be wary of, you know, the generalizations of, you know, the value proposition of your design, or the attributes, the positive attributes of your design. You also mentioned something to the effect that you have projection lengths optimized by building by orientation, is it?
Yes.
Okay. That.
We'll just go to that slide so we can.
Okay.
Yeah, you can stay here. So the 3 sections which we see on the left side are actually 3 sort of places where we are using different types of projections. So based on the north, south, or east, how we wanted to make it, we use different projections and different ways to sort of tackle the amount of light which was entering. So like, for example, the first one, what we see is the distance over there is around 1.8 meters for the balcony. And we also have a drop pardi which is being created by the sunk for the upper floor being the vegetative, like the vegetative part of the upper level. But when we come to the next, we can see that there is no such drop pardi or that vegetation which is growing. So instead, because this facade didn't require that much of a projection, we were able to eliminate that, the construction of that. But in the third case, we can see we needed more than just the drop pardi. So we also added 2 vertical slats, which we can see in the model as well, to again account for those. So we've done it according to the different facades.
Okay. And you mentioned rising temperatures in the future, and you will bring it back to past temperatures.
Yeah, so I'll rephrase that. So the idea is we checked projection summer temperature in Gurgaon to increase.
Based on?
We used the website of the ICPP.
Okay.
So we've used like the UN sources that have valid chart, the approximate degrees that it will increase. Then we took the highest average temperature that is there in Gurgaon, added that increase, and then checked the percentage. It's an approximate, that's why we mentioned 16%.
So how are you bringing it back to
So
past years?
it's not bringing the temperature back as such, but it will not feel as hot as it is outside. So the temperature drop ideally
Because of
due
the
to
landscaping.
due to the vegetation, due to the shading will be experienced, and the evaporative cooling also will be
And
experienced
for
as
that?
lower. Evidence
The
for?
evidence for land or
Yeah, so that calculation is done by, so we checked sources of I've written this, yes, the NBS, the National Based Solution, Nature-Based Solutions for Urban Resilience. So based on that, we took values of, each tree, how much carbon emissions they're doing, and averaged out the temperature drop that would be, and then based on
so
that.
one last question. I know
calculate.
we're almost out of time. Will Godrej Properties build your project?
Oh, we should ask them.
You should. If you're giving them 23 more units and 118 crores more. Rohit is a sharp guy, so I think he should be sharp to the opportunity. Okay.
One generic comment I wanted to make was, and this is not really a question, please understand that in architectural design, everything requires cost and space. So for example, you've said that, you are looking at some plant-based SBT filtration process system, you're looking at geothermal. These all things, while we are not questioning you hard on these, please understand that all of this requires quantum amount of space, which is why typically in a city development like this, you will see not like people don't want to do it, but they can't do it because of space constraint. So it will be nice for you to go back and check the space constraint, because this amount of, water filtration requirement for these many units is next to impossible with the system that you have proposed. So you don't need to justify that right now, but go back and check on the metrics.
I'll just add on to that as a general comment. I think that's a really good, So I think that it's great that you're presenting to win the Solar Decathlon India Division jury, right? But I do think that with everything that we do, the outcome that we want is that these things should be implemented and result in real impact. And getting to that outcome, I would encourage everyone in the room to think about, healthy skepticism and is this for real? Because if it is not for real and the healthy skepticism has not been applied, then chances are you're not going to get to execute it. It just won't come to pass. So.
All right. Yeah.
Thank you and well done.
Thank you.
Thank you, jury members. Thank you, Team Sanctum. Let's take 5 minutes and get ready for the next presentation. Our second presentation is from Team Adhyay. They have worked on Trihan Iris Group Housing located in Gurgaon. You have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation. After that, we will have 10 minutes for the Q&A session. Please keep your answers direct and to the point.
Good morning, everyone. Good morning, everyone. We are Team Adhyay, a climate-conscious and community-driven group. We are a collaborative team of University School of Architecture and Planning as well as IIT Roorkee. Our site is in Sector 80, Gurugram, which is a rapidly growing urban metropolitan. So looking at the demographics, the site basically caters to people with corporate jobs living in nuclear families, which was taken into consideration while building the units. Our site area is of 10 acres with a built-up area of 1,25,990 square meters and a total of 590 dwelling units. So the strength of the site is the proximity to the golf course, which ensures that there will be good daylighting and ventilation. Weakness includes the rapid urbanization of Gurgaon, which has led to water insufficiency, which can lead to scarcity of water as well as flooding. Opportunity, this site has great potential to be a model net zero building example, and for threats, the general public is not used to the building systems employed and might be hesitant to invest.
So coming to the design, our design strategy is rooted in climate responsiveness as well as community-first planning. We have employed a Z-shaped massing that helps reduce heat gain and is self-shading, and it also helps with natural ventilation. We have staggered the roof, as you can see, and that ensures solar PV efficiency as well as helping reduce the overall bulk of the building. We have also introduced green terraces, punched voids, and these staggered units, which ensure that the daylight penetration is quite optimal, and also a sense of layered privacy. All right, so our design iteration looked at a lot of options, and in the end, we chose our design after careful consideration. These reasons we mentioned. So we have various building dwelling units ranging from 2.5 BHK all the way up to 4.5 plus 1 BHK. Looking at we have also massed not in the north-south direction, but rather in the east-west direction. This helps avoid a lot of these north-facing apartments, and it ensures that we get sun for most of the time of the day to most of the apartments, and it also helps the sellability of our project because there is a cultural aspect to our design that is being sold. This is quite valuable when it comes to our project partner as well. Our architecture, as you can see, was inspired by traditional Indian housing. We have this community living aspect where we have embedded community spaces, and these are not added later, but rather integrated within our design. We have punched voids after 3 floors, and these act as vertical sky courtyards for optimal social interaction, because community building is something that we've heavily focused on. We have Z-shaped massing, which then further creates these shaded greens, and we have these shaded streets, courtyards, and also again the focus is on ventilation, privacy, and ease of construction. Our focus is on modular and modern and interactive housing.
So from what we've understood in our climate analysis, we see that one of the most uncomfortable months are from April to July in terms of summer months, and December to Jan in terms of winter months. And then we have the monsoon during July to September. So according to that, we inferred that major things that we need to consider in our design are A, sun shading and good ventilation during monsoon months, and proper sunlight during the winter months. So first we took a basic thermal analysis of a cuboidal form, and then we further developed it, optimized it, to reduce the overall thermal radiation that this space was receiving. So through mutual shading, the overall thermal radiation was brought down by 42%. So when it comes to engineering and operations, we right-size all the systems, building systems in our project, including the HVAC, the water system, and the energy systems. So we've used terrace-mounted solar PVs, solar water heaters, vertical wind turbines, and biogas generators to produce renewable energy on site. And we've used low-flow fixtures and grey water treatment to reduce our water consumption. So one of those structural innovations that we've done is to create those punched voids that we were talking about. We've used a T-girder. Now, T-girders are generally used in bridges for long span structures. So to create a sort of a space here, we needed something structurally stiff like that. So we've used circular columns from T-girder to T-girder, and these circular columns are also braced horizontally. So they're braced horizontally because we need to achieve a slimmer column, and they also help out with the seismic load. Then we've also given a basic timeline of the construction spanning 5 years and a comprehensive maintenance plan of the different building systems that we've integrated. Now in the HVAC area, so we've taken ambiator units instead of a split AC or a VRF system. Now why we've taken ambiator units? A, it's an energy efficient model. It's energy efficient. It uses no refrigerants, reduces GHG emissions, and has little to no carbon emissions. So we've also given these individual units, they're packaged units. So these packaged units have ducting running throughout the unit, and they cool the space according to the needs. So they're cooling key areas such as the bedrooms and the living rooms. These are the plans in which the ducting works, it runs throughout. So coming on to waste management again. So waste management, we've explored on two scales, the household scale and the site scale. On the household scale, the waste is divided into dry and wet waste. Wet waste, which is majorly biodegradable waste, is sent to the biodigester to produce electricity. And the dry waste, which is non-biodegradable, is further sent out for segregation. So this segregation is done in the 3-bin system, again, inorganic, organic, and e-waste. Organic waste is sent off to organic waste, which majorly includes sewage and other waste. So that's sent off to the biodigester. Inorganic waste is sorted throughout and then sent to the related authorities, and so is the e-waste. During construction, what we've done is we've had to segregate the different types of waste that we generate, including concrete, paper, plastic, glass, etc. And then that is sent to the nearby construction and construction waste plant in Basai, which is near Gurgaon. So that is where they process the construction waste, and it can be recycled later on. And we've also reused or we've recycled the construction water that was used and introduced algae to it for carbon sequestering. What this algae also does is it creates a certain biomass that can later be sold also. So this is one of the strategies that we've used. Then collaborative innovation.
Coming to collaborative innovation, the first thing that we did was create this app called EcoHome. And what we wanted to do with this app was basically not just have an app that tells you that you're consuming X, Y, or Z amount of electricity or energy, but rather tell you where exactly and how exactly are you using that energy, what appliances are using that energy, because we've tried to implement a lot of smart appliances in our design, and also how you can reduce them. So using digital twin technology, we have tried to implement the sense of energy efficiency, security enhancement, and also a sense of residential engagement. What this app basically allows you to do is create groups and engage in friendly competitions with them, almost to try and see who can save the most amount of energy. So we have also used this coolant passive cooling technology, and we have only used this sparingly in the open spaces, such as the vast open greens that we have given throughout the site, and also the massive stilted spaces. Now, what this does is that it helps our building just breathe better, especially in the hot and dry climate of Gurgaon.
Hence, coming to resilience, we have categorized resilience into 4 components, that is environment, community, economic, and structural. Talking about each one of them, in environment, we have catered high heat, water, air quality. In community, we have catered waste and pandemic by introducing biogas plant. In economic, we have catered energy efficiency and food shortages. Then coming to the structural, we have cooperated earthquake-resistant structures and fire safety by providing proper amenities. Then talking about heat waves and floods, these two are the most important calamities that can occur in Gurgaon. So for that, we have incorporated these passive strategies. Talking about thermobricks, which has a U value of 0.56. Then we have Z-shaped massing, which incorporates maximum daylight and reduces the overall heating effect. Then we have coolant structures, green terraces, solar panels, and biogas generators. For floods, we have rainwater harvesting, grey water treatment, flood-resistant structures, and elevated structures which prevent floods in our structure. Then we have highlighted following spaces which are utilized before and after disaster in such a way that makes our structure completely resilient. Coming to health and well-being, for our structure, we have used the massing model, and then we can see that our structure has seasonal radiations, and that makes it more passive strategy incorporative. Talking about CFD analysis, CFD guide for northwest and southeast direction gives us the appropriate wind and high pressure and low pressure zones, where the high pressure zones maximizes the ventilation and low pressure zones create wellness gardens. Then talking about daylight and lux levels on our site, daylight and lux levels are calculated such that it maximizes the daylight and thermal comfort into our structure, and then it meets the ENS guidelines as well, which is 0.5% to 2% of daylight factor and 100 to 500 lux level in our structure. Then thermal comfort, we can see the psychometric chart shows, and the graph shows that most of the months incorporate 600 hours of thermal comfort, hence making our structure appropriate for the users. Then we have ventilation rate, in which northwest and southeast orientation enhances the daylight and the passive heating and cross ventilation in all the rooms and all the spaces for our structure. Then we have utilized these human-centric areas so that humans are and the residents can be easily use our structure and have their time with the family and amongst themselves. Talking about the landscape plan, we have used neem and jamun trees maximum on our site, and so that they have helped us creating wellness retreats, gardens, cycling tracks for the users, making it more user-friendly and giving a perfect well-being to the residents.
Coming to energy performance, the baseline energy performance index for a composite climate residential complex is 85 kilowatt hour per meter square per year. However, we have managed to achieve a 33 kilowatt hour per meter square per year EPI through various techniques such as building orientation optimization, energy efficient appliances, and more. So coming to the passive strategies included, the northwest to southeast orientation of the building allows for greater cross ventilation, especially through the bedrooms based on the unit plans, which helps reach the thermal comfort levels. Also, the daylighting factor achieved is 2%, which allows for low lighting requirements. Coming to microclimating, various factors such as rain gardens, coolants, and the cascading green terraces lowers the temperature at the site, therefore reducing the cooling demands. Active strategies, multiple different renewable energy factors sources are being used to ensure consistent and resilient energy generation, 466 ISERT 1 kilowatt Helvig VWATs, 1 unit of bioficus biogas, and 4,000 solar panels along with 100 solar water heaters are used to create a total renewable energy of 52,54,800 kilowatt hour, which is much greater than the 41 lakh energy consumed per year. Therefore, creating a net zero building. This is the location of the solar panels and the solar water heaters along with the VWATs on site. Coming to the integrated grid system, so solar panels and vertical axis wind turbines directly feed the energy into the dwelling units. Excess is sent to the grid using net meters, and the grid is also used as backup in case of any emergency needs of energy on site. Coming to water performance, we have reduced the water demand from 135 liter per capita per day to 86.7 liters per capita per day, which is a 35% reduction in the water needs. The 4 main strategies used are rainwater harvesting, grey water treatment, low flow fixtures, and drought tolerant plants. The grey water is retreated using root zone treatment, and the black water is sent to STPs. This is the chart of the efficiencies, the grey water site. So the total amount of rainwater generated per year is 2 crores 56 lakhs, and it is further used using nano filters to be portable on site. These are the groundwater recharge techniques used. And finally, we have a surplus of 1.7 crore liters of water per year.
So coming to affordability, so we've taken an overall 10% reduction in the cost of construction, bringing it down from 738 crores to 627 crores. So one of the major reasons, why this cost of construction has come down is that we've considered the base case to be Maiwan construction. Since most of the developers in Gurgaon use Maiwan construction, we haven't used that. Instead, for walls, we've used thermo bricks, which reduce the costing instead of RCC walls. And the grade that we've used, considered in the base case, was M80. What we've used is M40, which again brings down the cost drastically. So if you look at it, the MEP cost of MEP services is again higher, but overall during the life cycle costing, we can cover it up. And we've also reduced life cycle costs by 68%. Coming to embodied carbon, in embodied carbon, again, we've had a 49% reduction in the embodied carbon. This is again due to the thermobricks. Thermobricks are a very low embodied carbon product, and they also using UPVC frames that reduce the embodied carbon overall.
At last, coming to value proposition, at Adhyay, we envision that we will create sustainable and easy to maintain homes for the users. Hence, we have zero maintenance design, predictable construction cost, green certified living, net zero energy homes, community-centric design, abundant green spaces, large balcony open spaces, safe and inclusive parking for the users. Hence, coming to the end, we have home designed for life. At Adhyay, we believe that home should not just be a shelter, it should be a proper living with all the sustainable measures. Thank you.
Thank you, team. You did a great job. Let's hear the jury comments and take questions from them. Alok, I'll start with you.
Sure, yeah, thank you for a great presentation, and congratulations for making it to this stage. What is the strategy on which the ambiator works? Like, what's the technology that it works on?
So basically, it cools down the way that a compressor works. The ambiator cools down the water that is used using evaporative cooling. It cools down air, not a refrigerant. So that's how it has lower carbon emissions. So since there's no refrigerant used.
Okay. I have a lot of questions, but I'm going to try and stay within 3 minutes, so we give time to my fellow jurors as well. Thermobricks, what is the reason that it has lower embodied carbon, significantly lower embodied carbon?
So first it uses, it's a hollow block. It's a hollow block with cellulose insulation. So again, it is patented. It's made by two companies that, from what we found, there's Wienerberger in Karnataka, I think, and one is Prayag Clay Products in Varanasi. So the one that we used was Varanasi one because the travel cost was obviously something we had to consider. So they had claimed that their low embodied carbon for a particular amount of cubic footage was this much. So from that I forgot, I'm not able to
That's
recall
okay.
the value.
How did you verify the claim?
We did not verify. We just asked them and we said we used what the information they had.
And you mentioned digital twin in your app.
Yes, sir.
You have any idea of what a digital twin might cost to build?
That was one of the soft costs we haven't considered. So we know what
I
the
reckon it would be
technology.
about 10 CR for your project. So I think even for large owner-operator portfolios, digital twins are still not cutting it in terms of cost effectiveness. You also mentioned the coolant system helps the buildings breathe better. How?
So in the areas that we are putting them on, they're usually the ones on the ground level, and over there there are a lot of areas without tree shading. So for most of the time in Gurgaon, you do have the loo season, and also you have quite a hot climate. So having that air pass through that coolant system, it just helps a little with the breathability, basically just cooling the air a little and helping create this more comfortable environment to be in.
You all live in NCR.
Yes.
Do you use evaporative cooling in your homes?
Does cooler count like that?
Okay.
Well, yes. Coolers, if a cooler counts in that sense, then yes.
Okay. Yeah, I'll hand it over to my fellow jurors.
First of all, congratulations and thanks for a concise presentation. I don't come from an architectural background, so explain to me, like I'm a 5-year-old, how this Z shape helps.
Okay. So the major points in the Z is that firstly, it creates two coats. The formation of the Z creates two internal coats, which which are self-shaded by the building itself. So it creates for like better comfort levels in the ground level. Secondly, the cascading terraces have green roofs on top, so it reduces the solar heat gain in the lower units, and also the east to west the slightly oblique orientation east-west helps to air to pass through, wind to pass through, creating wind channels and just greater relief to the overall structure.
So the benefits that you mentioned,
Yeah.
is that the only shape that can achieve those, or were some alternatives tried? You started off with these benefits in mind and then came up with the Z, or it's the vice versa?
So we started with various different forms. So basically the design idea was to create a community space. So the not only energy but also how people would interact with the space was considered. So you wanted to create courts as an initial thought itself because we wanted to bring the community together. So yes, of course, the idea of creating courts was influential to the Z shape coming along.
Okay. You mentioned that for addressing floods, you have 4 elements of your design that address floods: rainwater harvesting, grey water treatment, flood resistant structure and elevated structure. First, explain to me how the structure is flood resistant.
So we have, can we go back to the slide? Okay. So for the flood resilient structures, we have elevated stills provided, and the structure is built such that when the water comes in, the ground floor is not there, and it'll be easier for the users to move around at that time. And we have flood resilient walls that with the lower U value, which makes the structure more appropriate.
Is the U value correlated with flood resilience?
Not necessarily, but we have tried to cut down on the U value.
Okay, and how does grey water treatment help in flood resilience?
So basically, we incorporated a grey water treatment so that the access water comes to use, and that's how at the end we have some potential water to be used further in the structure.
Okay, okay, thank you.
Hi, lots of hard work. Congratulations. I had a couple of questions. First, if you can go to the cost slide, please. Yeah, just be there. So you're saying that proposed design estimate is 53,000 per square meter?
Yes, ma'am.
That's about 5,336 per square foot.
Yeah.
Do you realize how high that is for a residential project?
Ma'am, I mean.
So to give you an analogy, a large development like where you are currently standing, with the kind of amenities which is a project. So projects are divided into two parts, two typologies in terms of costing. One is an institute like this, which is revenue generating. So you can obviously pump in more money because there's a return on investment on making a campus like this, right? Infosys generates money out of this facility.
Yes.
But a residential project is not a revenue generating project. Yeah. And typically in India, people put in their lives savings into a residential project, even if they are high-end projects, even in HIG projects, right? So typically, to give you a comparison, a project like this would not cost more than 4,000 rupees per square foot. Okay, that's how high your residential project estimate is. It is almost impossible to spend 5,000 rupees per square feet on a residential project, right? In terms, and this is your cost of project. Okay. Remember, the developer is going to put 100% on this, and there is land cost and consultant cost and every other soft cost. Like you've added other software costs and all of these things into it. So if this is the cost of your project, it is practically not possible to implement the project. Okay. So I'm not sure. I've not gone into the basics whether your cost estimate is wrong, or as in you've considered things on the higher side, or you've just plainly taken things which are not within the budget. So if they remove land, which is what, 1,500 rupees per square foot, still it is very high. Still it's very high. So even if I remove the land cost, then also it's like very, very high costing. Okay, that's one. The second is, if you can go back to the layouts, I want to see what is the kind of building to building setbacks that you've taken, because with the Z shape, what does your bylaws say? Like one of the earlier teams had a 16-meter setback all around. So you probably will not require that higher setback within buildings, but bylaws definitely have a decent building to building setback also for high rises for this. And I don't see that in your layouts. So just go back and check on that. Okay, so building bylaws will need to be checked on that front if you haven't already. That corner over there and that corner over there, I don't think suffices for your building to
A
building
minimum
setback.
of 70 meters setback is taken into consideration.
17.
Sorry. Yes, 17.
How much is that corner to corner?
That edge, right?
This edge and that edge.
Ma'am, that must be at least 20 meters because the depth of one building is 15 meters, like one dwelling unit. So it's greater than that.
Okay, if
Yes,
that
ma'am.
is so, then it is fine.
Yes, ma'am.
My last question was that what is this requirement of the T grid? I mean, how does it really help you, and why do you need T grids to? In your presentation, you said because of your landscape areas to create that void, you needed T grids. Why would you need T grids for that?
So, ma'am, this is one of the things that we discussed with our engineering team. So, to create, like, they ran the calculations, and to create that puncture in that space, the slab thickness that had to be taken was around 600-700 mm. And according to their calculations, they recommended us that the T grid would be better with the circular columns that we had to provide. The T grid would be better because it would save on on our material costing by a lot, and it would transfer the load in the same way.
If I were you, I would look at a steel truss or something which is far more economical, and you'll have much more flexibility instead of this amount of concrete that you've used. Explore that option.
Yes, ma'am.
Thank you.
Thank you, ma'am.
Thank you, jury members. Thank you, Team Adhyay. We'll be taking a small 15-minute tea break before we begin with the third team. Tea will be served right outside the hall. Folks online, I request you to
The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through.
Welcome back to the presentations for the multifamily housing division. Our third presentation is from Team Jennis. They have worked on a multifamily housing project located in Nagpur. You will not have a 21st minute, which means at 20 minutes I will stop you and ask you to end your presentation. After that, we will have 10 minutes for the Q&A session. Please keep your answers direct and to the point. All right, team, all the best.
Hello everyone. This is Team Jennis. Hello to the jurors, presenters, and everyone present here. So in a world of rising urban pressure and climate uncertainties, the quality of life often comes with a price tag that many can't afford. In Nagpur, as after COVID, the demand of houses has increased a lot in the past 2 years, but the supply is still at 4%. So Team Jennis from IIT Roorkee consists of 30 individuals from MArch, BArch, and MDes, and we have collaborated with Elite Construction Co. to design a housing in Nagpur which is sustainable as well as affordable. So Nagpur, the orange city of India, is our site, and in this city, along our site, we have various user groups from factory workers, migrated families, and college students as well as some universities are there. So our economic background of users is between LIG and MIG. So there are various climatic extremes in Nagpur. The temperatures rises till 45 degrees. There has been cases of downpour of 135 mm in 3 hours and drought conditions in Nagpur. So it's a resilience wake-up call for this housing. So our site in Hingna district is around 1970 square meter, and we have a composite climate. The area around the site is mostly residential with a low-rise context, and various amenities are within 20 kilometers.
So on our site in Nagpur, temperature is exceeding like up to 45 degrees in summers, and intense solar radiation like from 5 to 6 kilowatt hour per meter square per year during summer, and wind flow is prominent wind flow is from southwest, and through the passive strategies we can like achieve 59% of the comfort hour. So in summary, through the design analysis, climate analysis, we need to respond in design to these environmental parameters of like to reduce intense solar radiation and temperature. So our design process.
So we had a build-up area of around 5,000 square meter. So for this, we first started with the basic form, and from the sun path, we got the orientation that is 10 degrees, the longer axis tilted towards the southeast direction. So from this form and mass, we tried 4 design iterations and did simulations. So in the third iteration, we received the minimum EPI, and as well as with its staggered forms, and we are receiving self-shading and natural ventilation. Because of the centralized cores, the circulation is optimized, and that's why we have gone with this third iteration. So in the housing, the number of units that we have is around 60, where 30 units are around 1 BHK and 31 are 2 BHK. We are going till the height of G+10. We are not exceeding 35 meters limit. So as per the 10 solar decathlon goals, we have added 2 extra goals of our own: waste management and social sustainability. And we have tried to achieve that through our design. So in our design, in the site plan, as we see, the front side is basically the commercial area for the shop for revenue generation for partner, our project partner. And we have, in the back side, we have 2 levels of parking, and we have achieved that through half basements. So we have upper ground floor and lower ground floor for parking. In the front of the site, we have a bioremediation plant where the water is being treated, as well as it gives a green landscape for the site. So we have used various native species such as neem, mango, amla, mogra in our design to create water resilience, as well as these landscaping is designed in such a way that it's layered. The higher plants are in the back, which shades the lower plants. So in the first floor podium, we have a kitchen garden given. So in this, edible plants are there. So the whole, the community kitchen that we have provided in our design uses these herbs and vegetables and fruits from this kitchen garden, as well as there is one kitchen garden in the roof.
So coming to the social sustainability, we have tried to zone our community spaces in 2 levels. In the first level, we have multi-purpose hall and gym and other indoor activities, along with community kitchen extending into the community garden, also the green terrace. And the next floor comes the kids play area and the senior citizen zone, where we have intentionally put in a very in a near proximity. And the next level, that's a roof terrace plan, where a lot of sitting spaces along with chance of more community interaction along with home gardening has been provided. So focusing on the mental and social well-being, we have also wrapped the whole building in more earthy tones and more earthy materials, that is terracotta. Also, we have integrated lime plaster in the interiors, though it's not market friendly. We are trying to look at in a very carbon sequestration strategy. So all the areas are extending into the green spaces. Balconies have been integrated with home gardening. So coming to the whole interior layout, we have catered all the five senses. So 5 senses comfort.
The community spaces not only enhances social sustainability, but it also promotes physical and mental well-being. The kitchen garden, the layout of our kitchen is deeply rooted to the practices of Nagpur, and we have also provided sitting spaces. The kitchen also promotes women empowerment by encouraging women entrepreneurs to open cloud kitchens as well as tiffin services. The wet waste generated from kitchen as well as from the apartments is segregated on source, and it is being used to produce biogas using 3 mobile biogas plants of 15 meter cube capacity, and they are able to produce biogas for around 23 hours.
So this is our typical floor plan. So we have tried to provide cross ventilation, like for 90% of the interior space is getting efficient cross ventilation, and from which we are able to increase fresh air circulation inside the building from 20 to 25 to 40%. And this is showing the indoor airflow CFT analysis, which is done, and we have also used fully openable window to maximize the airflow. Yeah, next. Yeah. Okay, so we have like the use of lime plaster is helping us to improve the indoor air quality, and also the indoor plants are helping us to purify the air, and we have treated grey water through bioremediation. Yeah, so to cater heat waves. Yeah, to cater heat wave, we have used filler slab, and we have used solar panel. Like also they are providing shading on the roof, so from which we are able to reduce that indoor temperature by 2 to 3 degree. And also other than cross ventilation, we are using active and passive technology like terracotta jali to reduce the impact of heat waves.
Provisionally, we have provided split AC as well, so that if comfort is not achieved through passive strategies alone, the user can achieve comfort through active strategies. So Nagpur receives a high illuminance throughout the year, but there is a very low illuminance in monsoon seasons, July and August. So we have done simulation for these 2 seasons, and we are receiving 300 lux in more than 95% of interior spaces in these 2 months as well. So coming to the interior layout.
So individual layouts have been designed keeping in mind the flex spaces. So flex spaces has a lot of unrealized potential in today's market, in the changing needs and changing family structures. So we have tried to integrate different strategies by including movable TV unit and retractable walls. So expanding more spaces for different times of the year and different times of the life.
So for structure, we have mainly used concrete and GFRP, and as concrete is very fire resistant, so we have used that. So to reduce the quantity of concrete used, we have right-sized all the columns based on the tributary area of the slab, and we have updated the report. We have used post-tension slab now, so we are not using beams anymore. So we have reduced more concrete in the process. So these post-tension stands are placed at 900 mm each, and they have the advantage of giving a more flexible layout for us so that the movable panels can move freely. And we have used GFRP reinforcement instead of steel, which is 1/4 of the density of steel, and like it's more in cost, but because it's 1/4 density, the overall quantity is reduced. So because of these strategies and because of using a split basement, like lower and upper ground floor, the excavated soil is being used to produce CACV blocks on site, and these blocks are being used in the walls as well. So we have reduced the embodied carbon to 75%. So by using GFRP instead of steel and CACV blocks in split AC, we are able to achieve this embodied carbon of 207 kg CO2 equivalent. So in the wall section, we have used 100 mm CACV blocks with in between 50 mm of air gap. In the outside, there is terracotta tiles, and in the inside, there's lime plaster. Through this, we are able to achieve the U value of 0.34 watt per meter square Kelvin. And in the roof, we have used filler slabs, which are producing a U value of 0.44. So in the individual room layouts, we have, with the sliding doors, we have given a panel of terracotta jali, which has a drip irrigation system over it. So when the water drips in peak seasons, like when the temperature is very high, the individuals can manually control the water in the system and open up the sliding doors to get in the fresh air, which is cooled passively by the system. So for fire safety, we have mainly given open cores, which are naturally ventilated, and like all the cores are very compact. So there is like with the compact floor area, the travel distances are reduced overall. So to ensure thermal comfort, all these passive strategies with them, and we have optimized the shading period. So we are giving shading from 21st March to 6th October, and in the southeast facade that we have these optimized shading devices that are placed. So with this, we are achieving the operative temperature of 20 to 25 degrees Celsius, the PMV of minus 0.23 to minus 0.25 with a PPD of 6%.
So in our design, we are able to achieve an impressive EPI of 18 kilowatt-hour per square meter per year, with the using of key strategies like from baseline, which was like 199 API. From that, we are able to reduce to like 18 from using like first was to the optimized orientation of the building and the building form, then optimized building envelope using like a U value of 0.3 for the walls and 0.4 for the roof, and then optimize shading, and then energy efficient equipment and an efficient HVAC, and then operational optimized usage pattern. So this is the detail of the building envelope, where we are using wall, which is using air gap plus CSEV EV block, and then we are using energy efficient equipment with EPD of 3 watt per meter square, and we are using efficient. This is highly efficient 5-star split AC system, and then for the lighting, for the apartment lighting, we are using LED light with 4 LPD, and then for landscape, we are using solar powered lights. And through the solar panels, we are able to, from the roof, we are able to generate 75,000 kilowatt per year of renewable energy. Yeah.
So we have also made an app that our teammates can show a mock-up of. We have made this APK version with our industry partner GrowthSwift. So this app uses smart plugs in for ACs as well as geysers. So these smart plugs are directly connected to the app, which gives a appliance-based data. And then for the overall energy meter, we have a Wi-Fi integrated into that, which gives us the overall energy of the unit. And it is also able to monitor water through a water sensor system in the inlet of the each unit. So this app is called Gridwise, and you all have the mock-up with you right now. So that is there. So it also helps users to make informed decisions by monitoring their day-to-day energy and water usage and create awareness among them.
So by using water efficient features and fixtures, we are able to reduce the per capita demand from 135 liters to 78.8 liters per day. And for achieving net zero water cycle, we are using harvesting rainwater, and we are also recycling grey water on site. For grey water recyclation, we are using bioremediation plant, in which the first tank is holding water for around 1 week capacity, and both the filtration tanks are able to hold water for 2.5 days capacity. Apart from the grey water recyclation, we have also provided strategies for groundwater recharge by using rainwater harvesting pits as well as permeable pavers and using water efficient landscaping. So we are able to achieve 95 to 98% self-sufficiency with only 3 months requiring municipal water supply, and this is the water balance chart.
So through this self-sufficiency, we are able to achieve drought resilience in the design, and by using native species which uses low water, we are further reducing the water usage. So these are the resilience strategies that we have used. And further, the cost of the whole housing is coming out to be 28,697 rupees per square meter as per the updated calculations, and the total project cost leads to 17.87 crores. Which is 28.3% less than the base case value. So this is achieved by using CACV blocks from site, using GFRP, which almost reduces the half of the cost of steel, and other similar strategies. So we are reducing capex by 8,036 per square meter, and OPEX by 56.86 rupees million. So yes, so coming to the value proposition, so we are trying to provide a quality of housing at an affordable price, so each individual can afford this. So like for a project partner, there are credit systems for the co-working space and community kitchens, which help them generate revenue even after selling it out to the users. For the users, the community engagement activities and the communal amenities present on the site gives them space that enhances their quality of life. And each unit is planned in such a way that there is flexibility. So users, as the adaptive families case, as well as the families adapt, the users can create spaces as per their needs. So this is our presentation. Thank you so much, and thank you for the time.
Thank you, team. You also finished well in time. Let's hear the jury comments and take questions. Yash, I'll start with you.
Thank you. Very nice compact presentation. And I also see that several of the comments given by us were addressed explicitly in the presentation. So thank you for that. A couple of questions. So there was a statement mentioned that you are able to produce biogas for 23 hours.
Yes.
So give more context to the statement. So 23 hours under what conditions, and
so from all the units, the population is around 270 people. So the total waste generated is 221.5 kg for the overall per day. Okay. And the organic waste of it is 60.75 kg. So we have given mobile biogas chambers. These are like drums, and each chamber is 5 meter cube. So we have given 3 of them. So total is 15 meter cube. So from this, when we are calculating the biogas generation, it's coming out to be like it can generate 23 hours of energy for
So
a day.
every day you.
Yes.
So in terms of gas generation, you are self-sufficient.
Yes,
Okay.
for each day.
Okay. Can you go to the affordability slide?
Yes.
Yeah. So what is contributing to your capex reduction?
So the capital, so it's basically we have reduced the quantity of cement RCC in the whole design, and we have replaced the steel as well with GFRP, which is half the cost of it. Like it's like the quantity is reduced half. Yes.
Yeah.
And further, we have used efficient equipments which are also affordable to the users. So we have got the price from different websites which are available to the users, as well as Amazon and many marketing websites that are there. So we have tried to reduce the equipment cost as well. So that is how we are reducing the.
Okay. And GFRP instead of steel, has that been validated to provide as much structural integrity over the lifetime of the project?
So we have found some research papers that state that it is giving more strength to the than steel, but yeah, more research is needed to be done in that case.
Okay. And what is the view of the project partner?
So actually, the project partner have already started the project, so they are halfway through it, but they overall like the scheme and yeah.
Okay. Thank you.
Thank you, sir.
Hi, congratulations. Good work. A lot of work done. So my question is in continuation to what Yash was asking. You say GFRP essentially, as I understand, and there could be multiple elements to it, it is used essentially in two areas. One is where GFRP is more water resistant because, you know, it's not iron based, right? So it is used in structures where corrosion can happen, which is like water tanks or, you know, underwater structures or exposed structures. The other thing is where lightweightedness is very important. So for example, if you're building a bridge, the bridge itself is a hugely heavy structure, you know, and you're spanning it and there are large spans and all of it. So inherently, so while it is taking care of the structure by itself, it has lesser load. So you have the strength to take load, but there is no dead load of itself. So typically steel and concrete have a dead load of themselves also, right? So while the slabs are carrying load on top of it, they themselves are also carrying their own load, right? So where it's very heavy structures, GFRP is used there, and two, where there is corrosion. And that kind of justifies their additional cost. You know, you have also mentioned that you are reducing cost by use of GFRP. That is totally unfound. Okay?
So what we found that it has 1/4 the density of steel, but it is twice in cost. But overall, the ratio is half. So we are reducing
it is far more expensive. Okay. So and if you use it in this residential complex for these two reasons, people generally use it because these two aspects are more important for them. The weight and the corrosivity becomes a more overriding factor over and above the cost of the material. You know, that's when they use it. So have a look at it. You may have your research to support it, but on the face of it, you are unable to kind of give that research to us, as you know, Yash questioned you. Okay, so that is one point. The second is that you have spoken about filler slabs. Where all are you using filler slabs?
Just on the most topmost level, roof level.
The roof level.
Yes.
Not the balconies and extended
No,
parts and all of that. Then it makes sense.
Yeah.
The last question is that you're using drip irrigation in terracotta.
Yes.
Now, typically drip irrigation, I would use, I mean, in North India, even in Nagpur and all, where it's hot and dry kind of climate, it is used in materials which can soak in a lot of water. You know, it has an inherent quality to hold the water, and then when air flows through it, it slowly evaporates and lets the humidity along with the, you know, cooler air kind of come in. How much water holding capacity will your terracotta jalis have to be able to support this system?
So it's definitely porous, but not as porous as the natural fibers we use generally in our evaporative cooling. But keeping in mind the durability of the sliding door, we had to go for terracotta, but not exactly replacing the fibers, natural fibers.
So you could look at
the
enhancing
porosity,
the terracotta with, you know, like a curtain element or something which can hold water, right? To enhance this concept of yours.
Yes.
Right. Thank you. Thank you so much.
Thank you, ma'am.
Thank you for your presentation and congratulations on making it here.
Thank you.
I have a few questions and I'm actually going to take off on like, so you mentioned for GFRP it's a quarter of the density and twice the cost.
Yes.
Therefore it's half of the, but what is the attribute that you're seeking from either steel or GFRP? It's the tensile strength, right? The density does not
Yes.
really matter. So I think that the comparison needs to be about tensile strength and cost and the relative benefit or not thereof.
Okay.
Or maybe you meant tensile strength, but I don't think that was the case. The other thing also was that you mentioned lime plaster, carbon sequestration, and some other attributes also. And it's cheaper.
Not cheaper. Definitely not cheaper.
Okay.
Due to the labor, it's on a costlier side because not availability of labor in the market.
Okay.
But over the time, it's gonna absorb carbon and it's gonna be more durable than the normal plaster we use these days.
How much carbon will it absorb?
The exact number I'm not sure about, but I think it's a proven study on lime plasters that it's gonna absorb till almost 40 years of its application, and it's gonna harden almost till 40 years. Even the water moisture content hardens it more. So normally when we use normal plasters, it's gonna peel off, but in lime plasters, it's gonna harden and increase the durability over time.
So why is it not used more often?
Because of the labor, and the process itself is more critical. The ratios have to be very properly done, and the application process is also very fine.
You also mentioned that the post-tensioning slab increases resilience. How is that the case? The post-tension slabs as a measure that increases the resilience of the structure.
So it increases structural resilience. So the structure is more safe in general.
How?
So because it's more, as per the normal slab, post-tension slab is more durable and can carry more load.
Is it? Shyam? Okay. Okay. You mentioned some PMV and PPD numbers.
Yes.
Okay. Can you recall those? I'm just like. Yeah.
Yes, sir.
So PMV of. So what does this mean? I'm like trying to understand. What are you saying?
So, sir.
And what is acceptable? Like, what's PMV of minus 23 to
predicted
minus
mean
23?
value. So PMV, the accepted value is minus 0.5 to plus 0.5 as per CBE. So we were able to achieve this from our design, like for different times of the year. And PPD should be below 10%.
Okay.
Yeah.
And why ASHRAE 55? Why not IMAC
Okay.
We were using adaptive model of like SA55
Okay.
here, so that's why.
But even IMAC is Indian model for adaptive comfort, right? I mean, that's the full form. Yeah. Okay. No, I think, I mean, a lot of measures that were like in the design. The community garden and the community kitchen and the kitchen garden, is that like something you see in Nagpur in terms of like, does that happen or?
That's the community kitchen zoning was done keeping in mind the cultural theme, but not actually done in Nagpur. It's generally we are trying to promote more community engagement and exchange. So we were experimenting on that part.
Okay, and you know, the last thing I had was like third iteration was the lowest EPI and the highest circulation efficiency, and that is why you went with that. What was the cost implication of the third iteration relative to the other?
So it was less costly than others because others have some structural things like the structure will increase the cost in other iterations.
Okay, all right. Thank you.
Thank you, Julie.
Thank you, jury members. Thank you, Team Jennis. Let's take 5 minutes and get ready for the next presentation. Called Pratik Grand Begonia, which is located in Ghaziabad, Uttar Pradesh.
Hello. Good afternoon, everyone. We are Team Chakra with a team of 11 multidisciplinary members. While working with our project partners, we have tried to tailor design solutions to best cater their project requirements. The team approach lies within initially identifying the underlying issues, analyzing them, and coming up with comprehensive solutions to cater to the issues at hand. The project aims to study the prevailing high-rise development trend in Siddharth Vihar, as it is very common to build the project that does not cater to the need of the people. Our project aims to challenge this by providing a well-planned high-rise design solution. So currently, having high-rise solutions near the site are limited. So our project seeks to bridge that gap. So Prithvi Grand Begonia is a proposed residential development located in Siddharth Vihar, Ghaziabad, which is a growing area with strong road and metro connectivity. The site is strategically placed near essential areas such as schools, railway stations, metro stations, all within a radius of 6 square kilometers. Our project partner Prateek Realtors, who was established in 2005, is known for delivering high quality projects on time. Next, I'll pass to Bhavya for energy operations.
Please put the next slide. Yeah, so starting with the design, architectural design contest. So in our side, which is climate, so we primarily focused on passive design cooling techniques. So starting with the first graphic of the form development, we took 4 stages to get to our final form. So stage 1, which was basically compact massing of the cuboidal blocks. What we did puncture the central courtyard to access more daylight, and ventilation. And in the last stage, we incorporated staggered volumes, and also we played some pushing and pulling of the form to get a basic shading to our whole tower. Then this led to the 3 typologies of our design. So the 3 typologies are C1, C2, and C3. Talking about their composition of dwelling units. So C1 consists of 2 BHK and 3 BHK. C2 consists of primarily 2 BHK only, and C3 consists of 4 BHK and 2 BHKs. So in vertical stacking, the C1 and C3 are placed alternatively, whereas the C2 is placed in the center, and above and below we have a vertical green cavities to encourage more social inclusivity. Now, further, one more part I like to highlight. Previous slide, please. Previous. Yeah, so one of the main contest, or I can say challenge, we focused, like when we give different typologies in a cluster, we compose them, we have to also see for the common shaft. So we also take care of that. Next. Then moving further to the wind analysis and sunlight analysis, which is carried out in order to get a proper placement of the forms on the site. So through doing the simulations, wind analysis and sun path analysis, we find out the iteration 1 is very much satisfying the whole needs, in which we have done the shorter facade placed in the southwest side, and also the longer facade is placed such like we are able to achieve a wind flow of ranging to 2.52 meter per second on lower levels. Then further talking about the sites, so we have placed these clusters in the center of the site, and then the fun number showcasing the centrally located amphitheater, above which a space frame truss was constructed, and above that we have placed solar panels. Then the second and the third play area and swimming pool are placed in the corner of the site, so to get a shade of the build-up during the day. Then the biogas is segregatedly placed in the site, so to get rid of the fumes from the biogas. And also we have given a small land of farming, so to encourage agriculture on the site, and also to support the local production of greens on them. Now moving on to engineering and operations.
So for engineering operations, our structural design follows IS codes. Next slide. So for columns, we have taken the size of 900 by 300 mm to 600 by 300 mm, and the slabs ranges from 150 mm thick with Fe500 steel. We have prioritized constructability and local sustainability. Materials like Vedic plasters and gypsums were locally sourced, cutting cost and carbon footprint. Smart energy systems, including hybrid solar panels, passive cooling strategies, and biogas treatment improved operational efficiency. Next slide. So for water conservation strategies on site, we have used sponge roofs for rainwater retention, grey water recycling for flushing and landscaping, and concrete mixes with internal curing agents to reduce water use. To conserve energy during construction phase, we have used, next slide, is it previous slide? Previous. One more, yeah. So we have used passive cooling strategies, LED motion sensor lighting, and hydrogen fuel cells in place of diesel generators. So the performance highlights in our design is we have achieved 49% reduction in water use, 43.5% EPI drop, the 48% energy needs are met on site while achieving 92% of total carbon emissions. For indoor air quality, we have used low VOC paints and air earth filters. Waste is managed via dedicated chute system and categorized into dry, wet, and hazardous. FlexiBiogas technology handles wet waste on site, generating over 1 lakh kilowatt hour per year in clean energy. Now passing on to Bhabe.
So moving to the next contest, which is collaborative innovations. Our project innovation stems a strong interdisciplinary collaboration for architectural sensitivity and engineering pragmatism. So talking about the team only, the team brought together architecture students skilled in passive design, landscape integration, and vernacular techniques, alongside a civil engineer student, which helped us in feasibility and structure. Next slide. Yeah. Now, focusing on the three key innovations emerged throughout the design. The first one is a Vedic plaster layer over the gyprock wall we have used. So the Vedic plaster, our team revived these traditional techniques, adapting it for high-rise through research and feasibility. With material support and thermal testing from our industrial partners, SSB and SlipTech, we found out it significantly outperformed the conventional plasters, offering VOC-free interiors, improved thermal insulations, and 100% biodegradability. Then moving next to the hybrid solar wind energy system. So we integrated a rooftop system which combines the solar panel and vertical axis wind turbines combined together. And then our project provides the advantage of high rise, which will lead to an adequate amount of wind. So we integrated the wind turbines also. We considered the wind turbines also for the production. In this system were vertical axis wind turbines housed within a wind acceleration shell, like it is demonstrated in the model, which also helps to improve the wind flow from these systems. By guidance of SlipTech, we analyzed the structure and the feasibility of the system. Also, I would like to highlight this system is offsetting 10 to 15% more from the conventional separately integrated solar panels and wind turbines. Then next, the automated drip irrigation system designed by our landscape certified team members. The system delivers precise water to plants' roots, reducing runoffs and evaporations. SSB architects guided the selection of drip components, ensuring systems seamlessly blend with passive cooling strategies. This improved not only the thermal comfort and air quality, but also lowers the facade temperature and supports us to how to use the recycled water efficiently. Now, handing over to health and well-being.
So in the health and well-being part, firstly, we have used the terracotta jali system. So terracotta jalis are generally used in the balconies and the staircases. So these not only filter natural light or absorb the extra heat, but also regulate the indoor air temperature around yearly. And also ensure the indoor comfort and reducing the cooling loads. Then on the second, we have used the green wall systems. So green wall systems are generally used on the balconies and the staircases. So they are green wall systems ensure that the stress level is reduced and also CO2 levels are reduced for the occupants so that the mental and the physical well-being is ensured. Then terracotta bird feeders and effective shading are also added so that the social and the emotional well-being of the occupants can be increased. Then buffer plantation systems are used, which reduces the CO2 levels from 2000 parts per million to 800 parts per million. Then low in the interior, we have used the low VOC paints, which further reduces the VOCs in the air to 0.3 gram per cubic meter. Then these are the overhang analysis. So according to these are the simulations that we have run. So the size of the windows have been provided according to the orientations of the window wall ratio. So in the north, we have the window wall ratio is around 30%. In the south, the window wall ratio is around 18%. And on the east and west facades, the window wall ratio is around 14%. And also in the interior, we have used a natural plaster, which keeps the home cool. And it is made up of gypsum, cow dung, mud, citric acid, guar gum, and water. So it is very biodegradable, and it is applied and rest for the 24 hours. Next slide. Then this is the table which shows that the ventilation rates that we have tried to achieve is around 5 to 8 liter per second, but we have achieved more than that in every area. Then this is the air earth filters. These are our project partners also, and we have used this system in a mechanical ventilation systems, which reduces our air quality index by 60 to 80%. And also it is much cheaper than the conventional air filters from 40 to 60%. And also it uses less energy than our conventional air filters. Then this is the lux level, which we have simulation, which we have calculated. So the target lux levels that we have tried to achieve is around 100 to 300 lux in every area, except the corridors and the dining areas. And these are further, the two charts are the simulations that have been run on Design Builder and Honeybee, which shows us the comfortable hours in the which come around the range of 6,600 to 8,000 hours per year. Now Baba will tell us about the energy performance.
Yeah, so the first graph shows the comparison between the base case and the proposed case. For the base case, we have an annual consumption of 81 lakhs 40,000 and 276 kilowatt hour per year. And talking about on EPI, EPI was 69.26 kilowatt hour per meter square, which we cut it down to 39.16 kilowatt hour meter square, resulting in 43.5 percentage of reduction in EPI. Further, I would like to add, we are generating 48% of the total energy needs on the site by the renewable sources we have implemented. So there are a variety of renewable sources like the solar wind hybrid system, the biogas system, and some solar panels which are integrated all over the sites. The four main parameters we considered, and we are able to manage to bring that API down. So the first one was the envelope, second one was the window wall ratio, and the third equipment ratings and orientation of the buildings. So this chart shows their individual contribution to the reduction of EPI, ranging for 10.5% to 18% for the efficient equipment and 10.5% for the passive cooling and daylighting. Next slide. So talking about the methodology, we didn't really relied on simulations, primarily relied on simulations. What we did some simulations regarding daylight and thermal performance. And after that, we have made, the next slide please. We have made this Excel sheet comparing all the dwelling units, their EPIs. And what we have included in them, the equipment, number of equipments, their power density, the diversity, and the number of hours they are operating. And after that, we are able to see there is so much reduction in these typologies without integrating many different renewable sources, which will ultimately end up increasing our affordability factor. Back slide, please. Yeah. Then talking about the smart grid integration and some methods to save energy, we integrated energy efficient elevators, we integrated smart meters, G2V systems for EV chargings, IoT and HAN is also incorporated in this design, occupancy sensors, yes, lighting control, and in the last, energy storage for keeping the design reliable and resilient. Now, shifting over to water.
So for the water, we have proposed 3 overhead tanks, each with a capacity of 70,000 liters. Hence, the overall capacity becomes 201,000 liters. Each residential cluster is supported by an underground water tank. These underground tanks serve dual purposes, which is a dedicated fire tank with a capacity of 70,000 liters according to NBC. Then we have prepared the base and proposed case according to Griha manual, in which the consumption per day of a person stands out to be 136. But in the proposed case, we have reduced it down to 69.5, in reducing the consumption by 49.08% using aerated fixtures, low flow, dual flush, water tanks, etc. The base case, the base, next slide. Time is up? No. Okay, oh sure. The base and proposed case for landscape water demand calculations are also calculated from the Griha manual, reducing the demand from 37,096 liters per day to 11,452 liters per day, achieving a 69.1% reduction. The rainwater, so the rainwater is collected from the roofing, hardscape, and softscape, harvesting a total of 1 crore 55 lakhs 59,457 liters in a year. We've achieved a net positive in water demand. The total water demand, including domestic and landscape, in our proposed case, according to Graham Manual, will collect 1 crore 55 lakhs 59,457 liters from rainfall, and will filter out 4 crore 23 lakhs 53,505 grey and 1 crore 82 lakhs 12,040 black water using biowater treatment plant, getting a total of 7 crore 61 lakhs 25,002 liters of water. Now moving on to next slide.
So in our design, we have made a targeted and data-driven material selection, and for that we have used the Saint-Gobain gyprock assemblies finished in Vedic plaster rather than the conventional monolithic walls. And these were plastered in Vedic plaster, which is made from mud, lime, and cow dung. Then our roof emissions were reduced by nearly 6%, and fenestration, which is generally a higher emission component, that was optimized by almost 82%. This was done by using fenestrations that were glazed with double glazed panels, and they also were of low emissivity pristine white glass which reflected UV and infrared rays while allowing visible light into the premises. This reduced not only the heat gain in summers but also maintained the winter warmth to stay inside. This contributed to both operational and embodied energy reductions. In terms of total carbon reductions, we have reached a 92%, next slide, 92% of carbon emission reductions. And even though transport emissions rose due to the broader sourcing, like the use of EPDM strips and FC boards, the combined gains from low carbon assemblies still dominated. Moving on. Resilience was based on three key components: mitigation, response, and recovery. Mitigation included proactive steps that reduced future risks, response, which prepared immediate actions during or after disaster, recovery that sped up and ensure effective return to normal, focusing on the recovery and repair to rebuild efforts. Next up, Dhruv will say.
Next slide. Next. So this is our affordability table. So this is our project summary table. So we have reduced the civil works per square meter cost from 11,925 to 10,663, and the baseline estimate of the project was 283.7 crores, which has been reduced to 272.01 crores in the proposed estimate. Next slide. Bhavan, next slide. operating cost. So these are the materials and strategies that we have used in a project, and the table also shows that how we have reduced them. And in the operating cost, for example, we have used hybrid solar system, and which reduces our electricity bills by 34 to 35%. So from the table, we can infer that it is extremely affordable for the occupants, as they have to pay less for the services like electricity and water, and also the maintenance cost is also very low. And from the table and all the strategies we have adopted, we have reduced 58.69% in the life cycle cost using these strategies. So now value proposition will tell us, Baba will tell us.
So for value proposition, this slide outlines the dual proposition offered by the project partners for both the end users and the project partners. So for residents, the focus is on well-being and affordability. Hybrid solar panels ensure 64.22% savings on electricity bills, promoting sustainable and low living. Site prominently to Noida Electronic City makes it ideal for professionals, while EV charging stations at home support green mobility. For the developers, the project ensures economic viability and faster delivery. Used of gyprock walls, ACC blocks, and Vedic
I
plaster.
have to stop you there. Thank you. You all did a great job. Let's hear the jury comments and take questions from them.
Hi, all good?
Yeah.
Great. Great, good work. And I like the practical side of the architectural design that you've done. It's totally implementable. So good work with that. While you've kind of tried to make it sustainable and other things, you've not kind of slid yourself into non-buildable territory. So good for that restraint. One of the things which I want to question you on is this, this prototype that you have created here. Have you done wind data analysis of Ghaziabad, and does it support this system?
Yeah. So we did the wind analysis part for Ghaziabad. So according to the power law model, which seem that according to the height, the wind speed will raise. Or in the lower levels, we are getting from range of 1 meter per second to 2.5 meter per second. And for this system, we only want the cutoff margin of 3 meter per second of wind. So at the height of 100 meter above from the lower level, we are very much achieving the required wind flow.
And for how many months are you achieving this?
We are not basically targeting for months. We are only focusing, we are only implemented this system. So to complement the solar panels only. Like in the cloudy days, in the windy days, the solar panels won't create much. So it's just a part that we are making this system a reliable system that you can cooperate or in any housing, which would help to make the whole renewable part a reliable one.
I understand that. What I'm asking is that, this 3 meters per second that is required for your system to work, you must understand that how much part of the, because you see there is a sunk cost in putting this up as well, right?
Yeah.
So you need to have it for the better part of the year to be able to complement your solar system. So I wanted to understand that for how many months in a year in a place like Ghaziabad, the wind flow is available for you to make this system work.
So after doing that research, we find out the August and September months would be the months which won't able to cut off the wind. But apart that, these are in kilometer per hour. So apart that, all this wind speed will automatically cut off the part. And also one extra thing I want to highlight in the system, it's wind shell. So there is this shell design on this part. So what does these shells do? They also help to encourage the wind flow from these systems. So also one part I like to highlight, if we integrate solar panels only, so that will cover the area. In this system, we are catering the area for the solar panels also. We raise them and we put the wind turbine inside. So it's very much efficient in basis of area.
Sure. My next question was, you have mentioned HEPA filters. In a residential project, where are you using HEPA filters?
Can you please switch out to that?
Yes, this one. Where are you using
So
this?
ma'am, these are the filters that we have used in the mechanical system, in split AC system. Whenever we hand over the project to our occupants or the consumer, the split ACs will have these system, which further reduces our air quality index.
So
And in
when the split AC is running in a
Yeah.
in a summer situation,
yeah,
that's
so
when
they
your
will-
HEPA filter is
yeah, they will.
running.
And also we can switch them to the our fan mode so that in the winters or in the other seasons they will work also.
So what you're saying is that your split units, the
Yeah.
high walls,
Yeah.
the normal filter is replaced by this HEPA filter.
HEPA and
Is
yes.
that a possibility? Do
Yes,
the
ma'am. Ma'am, these air filter is a company that have been doing this, and also they have been tested their prototype in Shark Tank. Also, they have well, these are running in
and
the
is there
current
a
market.
is there a way where your system can without cooling just run through the day like a
It could work on fan mode only.
Yeah, it in the winters also they can work on the if you turn on the fan mode, they can also work that.
So you're saying that in effect these high replace the filters that we buy in Delhi NCR and install?
Yeah, definitely.
Okay, it would be interesting to see if that is a possibility. Thanks.
Thank you. I'd like to reiterate what Sean said. You haven't gone overboard with any of the numbers. All of them look achievable.
Yes.
Yeah. I have a couple of questions. I think some of them will be extensions of what Sean asked. For this hybrid system, you mentioned that it will be 10 to 15% more efficient, or it will generate more power than if I use the two separately.
If you use separately the solar powers and windmills, if you use separately, then this system will offset them for 10 to 15%.
Why?
So it's because of the part that when you implement a windmill on a site, so it will cover the area and it will require a height to generate offset. And also for the windmill, there is a cutoff of 10 to 12 meter per second to cut off. So shifting to this system, if you use this system, the area efficiency, as I have mentioned earlier, the area efficiency is doubled. Like you are also playing with solar panels, you are also playing with the wind turbines. Apart that, this shelling part, like the part, the company are claiming that it will increase 140% of the wind flow by doing this shell system around this block. So
And see, a turbine is a mechanical system.
Yeah.
And every mechanical system requires periodic maintenance. Do you think your hybrid design will hinder the maintenance aspects of?
it will hinder, but it's not a main concern because solar panels, if we include solar panels, so that will take the maintenance. The only maintenance adding is the solar wind turbines. So we did research on the maintenance part. So they are claiming it requires a maintenance after a 1 year, and that will no cost, मतलब that will cost barely कि आपको एक system लगाने की रोक सके वो चीज मतलब. If you wanted to implement the system.
But, the accessibility of the wind turbines.
Yeah, it is talking in the terms of dimension. It is 4 feet high. The solar panels are 4 feet high. The wind turbines are running below them. And apart that, we also did an offset of 2 feet or 3 feet from the roof terrace level. So it is very much ranging in the anthropometry of the maintenance part.
Okay. You mentioned Vedic plasters, and you. First thing, in some places you mentioned natural plaster, in some places Vedic. Are these referring to the same plaster or?
Yeah, they are referring to the same one.
Yeah, so you have given a lot of benefits of Vedic plasters. So why are these not commonplace? What is the challenge with adopting?
Obviously, the labor would not be the normal labor. It would require some extensive labor part. And apart that, you also have to do some mixtures in the plaster only to get some strength and water durability. Like you have to add lime to such percentage so to get a proper strength and proper connection with the building mass. So yeah, that's why I think that's the reason they are not implementing.
So have you incorporated the additional cost in the affordability?
Yeah, we are implemented the cost. We have also mentioned the cost is comparable if you don't add admixtures to it. But if you want to add some admixtures, so lime or something, then we have added the additional cost.
Okay. For the air filters, see, you are adding a HEPA filter on the top of your air conditioner.
Yes.
The power consumption of the air conditioner will shoot up.
Yeah.
Because there is restriction to, the airflow.
Okay.
So has that been accounted? I might get purified air, but I'll be paying much more in electricity bills.
So for electricity bills, we have used several systems like the electricity bills are further reduced. Can you please shift to that table in
No,
the
so-
operating cost?
But those systems will work irrespective of the air filter, right? So what is the electricity, additional electricity required because of the addition of air filters? Has that
Yeah,
calculated?
so for that, there is no dependency on electricity for that.
No. So your air conditioner will draw more power because the airflow is now restricted.
Yeah.
And this, I think, is like a known problem in the market for air filters.
Okay.
Okay. And one final feedback, so this is not affecting your scores or anything, but not only for you, but for several other teams, trend is being seen that most of your report work has been being put in the PPT slides, and these are very text heavy slides. So the presentation could have been much more, summarized and focusing especially on the aspects where you want to draw our attention.
Yeah, pictorial.
And even the numbers, like you don't need to speak out the numbers to the last unit. You could just say 1.5 crores instead of 1 crore 50 lakhs. Yeah, so just a minor feedback.
Okay.
We'll work on that, sure.
Yeah, thank you.
You doing all right? Can you hear me?
Yeah.
Okay. So yeah, good work. Again, congratulations on getting to this stage and on getting back to this stage. Similar questions. With the natural plaster, can you go to that slide? My experience, I think it
previous
was,
slide.
no, this one, yes. So you say gypsum, cow dung, mud, citric acid, guar gum and water. My experience with a lot of sustainable alternatives usually is that while the alternative in and of itself might work, the availability at scale is an impediment to it taking off. Right? So I find it, मतलब शायद गाजियाबाद में इतनी गायें और भैंसें हों कि इतना सारा काउडंग मिल सके हमें, बट 29 स्टोरी बिल्डिंग के लिए मुझे नहीं पता कितना वो काउडंग और गुआरगम लगेगा, और is there a mass manufacturing facility for this plaster, or is it who makes this?
It's made on.
Okay. Yeah, so that I think so again, the healthy skepticism about everything, a lot of innovations and a lot of ideas in a lot of the projects, including in yours, but the healthy skepticism in the studio at the report stage, at the presentation stage, before it goes to the project partner or the developer, will ensure for a more rigorous solution. That's one thought. Then I had some question about the terracotta jalis, but I forget what it is, so maybe I'll move on. What did you use for this overhang analysis? What was the tool?
Actually, these simulations are run by our teammate. It was run on design builders and some part of Honeybee.
And also these are provided in the toolkit of SDI only. So we have run from that only.
We took the inputs and parameters from there and we did the simulations.
Okay, and you made a remark that AAC blocks are 28% cheaper.
In the affordability. Yeah. So basically in the baseline case, we have My1 construction. So we have compared to that whenever we have used AAC blocks in the interior section. So they are
cheaper compared to what?
to the baseline.
Which is what?
Just My1.
My1 construction.
Who is using My1 in interior walls?
Our project partner had done this in the phase 1 part.
And isn't My1 a shuttering system? It's not even a walling system.
So My1 is the aluminum shuttering. I mean, My1 is it's like Godrej Kalmari or Singer machine. Okay, so My1 is a company name to a shuttering system. And plus, unless you're doing shear walls, you wouldn't use that shuttering system. If you're saying that I'm replacing brick with something, then My1 becomes irrelevant. My one is used only where if, and in large residential like this, of course shear walls are used for structural designing, but you can't replace that, compare that with other brick walls that you're using.
The normal one, the conventional method. Yeah, it will be attached in the split AC. Yeah.
Yeah, so they are also talking about the replacement of that filters only. Like if we replace that normal filters from this one, then we could improve very much on air quality. And also apart.
A replacement for the
Jali. Yeah.
Yeah.
With the air filters.
And I think the remark was that it reduces energy use, but I think Yash has already used less energy than conventional air filters.
The
And it would be mental air purifier. Oh.
Yeah, then the air, conventional air filters.
Yeah, because if it's a more effective filtration medium, it means it will be more.
Yeah, because it will work with the split ACs.
More energy intensive.
Yeah.
Okay. Is the hybrid and solar system having a close second in terms of the jury interest? Is it something that is, I mean, how are you integrating it? You're going to build the integration on site? Is it, are you going to commoditize the product?
So there is a company named PowerNet who have done this work before in foreign countries. So we are almost duplicating their iterations for our residences, in which we have done some normal tweaks with the dimensions to get a better airflow in the system.
Anyways done. Yeah, sorry.
So yeah, I was saying that PowerNet is a company which was doing this practice in the foreign countries. So we are duplicating their prototype only. Apart that, what we are doing, we are iterating some dimensions to get a proper airflow in our cases. So there is not much needed tweaks in this prototype. I would say it would only just कि आपको थोड़ा सा height में आपको dimensions में फर्क करना होगा, and you could be good to go.
What is the per unit cost?
Sorry.
Per unit cost of this?
Per unit cost.
The total cost.
Have you incorporated the cost in your cost
the
analysis?
So the total cost of this was around 40 lakhs that we have calculated in the affordability list. It is not there in the presentation, but it is there in the report.
Okay. So, and does that include the modifications that you're talking about?
Yeah, the total cost of the.
The modifications are only on the basis of the dimension, as I'm mentioning. So,
But if it is a manufactured
yeah, it
unit
will-
and you're making a modification, then it's a custom
custom made, and it will
unit,
require
right?
more material, like the shells, the number of shells will improve, and the turbine will get more rate.
Okay, all right. I think that's all I have. Thank you.
Thank you. Thank you.
For lunch. Before that, I request all the teams to keep your component models outside along with the tent cards so that photographs can be taken. We will start with the presentation for Team Koutram at 2:30 p.m. Folks online, I request you to tune back to this channel and be ready for the presentations of the upcoming teams.
Solar Decathlon India, what's it all about? Net zero building, what's that all about? Solar Decathlon India, what's it all about? Net zero building, what's that all about? Is it cool? Is it hot? Is it drool? Is it fat? What's that all about? Real world problems need innovative solutions. If you don't act now, there will be implications. Is it hot? Is it cool? Global warming would be cruel. You will form a team with the same desire. Going for the moonshot, forged by fire. We use technologies and crazy simulations. We learn to design with new innovations. So what you waiting for? No procrastination. Get off your butt, come join our workstation. Solar Decathlon, India, what's it all about? Net zero building, what's that all about? These problems are tough and complex too. Your partners are there to help you get through. This challenge is exhausting, intense, it's a drill. These 10 mad contests will sharpen your skills. Net zero energy, water and stuff. And affordable too, that's crazy enough. Solar Decathlon, and your heck, it's really tough. But your attitude and grit is more than enough. Get your hands dirty on real world projects. You're gonna learn more than your specialized subjects. Solar Decathlon, India, what's it all about? Net zero building, what's that all about? Cutting edge, butting edge, climate wedge, make a pledge. Do it all, save it for a lonely planet after all. Understand, climate friend, take a stand, make a trend. In the end, recommend, your ideas will have defend. Are you hot? Are you cool? Are you gonna be a fool? Zero heroes are here to stay. So what you waiting for? Come join this play. Net zero building, that's what it's about. Solar Decathlon, India, that's what it's about. SDI.
Pick a site on a railway track. Put your building on an earthquake crack. Cutting million trees and planting roads and houses with their electrical loads. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Put your building facing west. Make a toast of every guest. Concrete, steel, here and there. Carbon emissions to poison the air. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Forget to put a bathroom drain. Add handrails that cause you pain. Elevator shafts that taper down. Bad staircase trip over your gown. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Start building with no hard hat. Walk barefoot, toes go splat. No gloves on, no goggles too. I wonder what these wires do. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Building on a melting glacier or a floodplain. Letting all your rainwater run down the drain. Heat the earth enough to fry eggs on the sidewalk. With homes that must have ACs always running. These mistakes we make are all avoidable. And that is why we must let go of these dumb ways to build. Dumb ways to build. Dumb ways to build. So many dumb ways to build.
Build less, build smart. A message from Solar Decathlon India.
world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world's so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through.
We will now continue with our presentations. Before beginning with our next presentation, I would just like to announce that after all the 7 teams are done with their presentations, we'll have a Q&A for all the 7 teams. So please request you all to be here during that time. That will be around 4:30. So please be here. Now let's move on to our 5th presentation, which is Team Koutram. They have worked on a project called the Elites, and which is located in Bachipalli, Hyderabad.
Namaste. We are Team Koutram. We are from Jawaharlal Nehru School of Planning and Architecture, and our project partner is SRR Group. Long ago, homes followed the sun, wind, and rain, and stories were shared under courtyards. Koutram brings that way of living back with climate in mind and tradition at heart. So, our team is inspired by Hyderabad's rich cultural windows, which are shaped by culture and climate. In our design, we balanced airflow, light, privacy, and beauty to create a comfortable home and a familiar structure. So this is Team Koutram, crafted by climate and inspired by tradition.
Our project is located in Bachpalli, set in the growing suburbs of Hyderabad, which makes it ideal for our Koutram. And our project partner is the SRR Group. The site covers an area of 2.6 acres, and the built versus open is approximately 45% for our proposed design. The site has an approach proposed road of 12 meters and is located in a residential zone. So on the east and south side of our site are the residential buildings, and on the north and west there are open spaces. And there's a small canal further on the north side of our site. And there's a hospital right 160 meters from our main entrance. And we all know that Hyderabad is known for its thriving IT industry, with most of IT hubs located in the western parts of the Hyderabad, providing convenient access to these employment zones. And also Bachpalli provides an affordable option for young families who have recently secured jobs, offering a more budget-friendly alternative to buying property directly adjacent to. So Bachpalli offers a balance between city life and the familiar atmosphere of villages and towns, making it an ideal destination for families who move to the city for job opportunities. So coming to the climate, Hyderabad has a composite climate with three major seasons being summer, winter, and monsoon. The maximum temperature reaches up to 41 degrees in May, and the minimum reaches to 11.7 during winters in December. And the maximum rainfall is in July. And the wind directions prevail from west between May to September, and from east between October to April. Coming to the solar radiation analysis, the heat gain is maximum from the south and the least from north direction. And the building envelope with roof has 946 kilowatt hour per square meter of solar radiation.
Our design connects traditional and modern living by transforming spaces, such that our busy streets here are converting into lively plazas, and our courtyards open into lively corridors, and backyards are becoming balconies, and verandas are leading to foyers. This approach makes home feel more familiar and fresh. So these are our design iterations. Our main objective is to retain the courtyard itself in the center of the site and allow the vents seamlessly towards the site without the turbulent winds happening there. And during the process, what we have figured out is that by keeping a staggered formation, it allows more courtyards to fit into the site and also allowing all the natural light to seep into the ground floors. That's how we reached to this last iteration. And by all of the massing iterations, this is our final model. And coming to the site plan, the entrance is situated here because there is a left approach road turning us this side, and we have another plot here, and it has an entrance over here. So that is why I chose this entrance, which is a 12-meter wide road. And after the entrance, we have divided the site into 3 blocks, A, B, and C. And the A block, we have kept the staggered formation with the courtyards here. And for the B and C blocks, we have provided a parallel corridor system, open corridor system, so that they can have interactive space and also a safe, secure environment so that they can interact more. Coming to the floor plans, we have tried to begin with the traditional system itself. Entering into the home should feel like a hygiene space. So entering itself, there is a veranda where you can wash your feet and go inside the living room, which is spacious and an open floor system, so that it leads into the bedrooms and balconies, where the balconies are strategically placed according to the private spaces, and also giving more interaction to other residents as well. This is the sections where we can see the open floor plan system and open corridors. They are singly loaded for the B and C blocks. And this one is the northern facade, which is allowing the ambient light. And here are the corridors. And this is the west and east elevations, and that is the dining space leading to other balconies. And that is how the verandas are placed in the front foyer, which goes into the living room, and there is a courtyard among the staggered spaces. And this is the parking layout from basement 1 to basement 2, with 50 guest parking and 14 car parkings provided.
Coming to the engineering and operations, to save resources and reduce cost, the building is designed with smart and efficient systems, which means choosing the right size, materials, methods, and systems. In the construction management, if you can see in the plan, there are sedimentation tanks positioned in the site, which collect and filter the water from curing and washing of equipments. Batch concrete mixing is used rather than precast because due to the excess transportation emissions. For the construction workers' housing and for the office buildings, shipping containers or modular structures are used to reduce the material waste, and solar power lights and fans are installed for the workers' comfort. This is the footing layout for the whole site. And additionally, crushed and reused concrete and bricks used for the road sub-base or non-structural filling. Coming to the waste management, a two-bin system is used for the dwelling units, and an organic waste of 6.3 tons is collected from the dwelling units and 0.1 tons from the garden waste. The garden waste is composted and reused for the landscape purpose. And from the inorganic waste and e-waste, like plastic, cardboard, metals are collected of 2.5 tons, and they generate a revenue of 34,000. These are the footing layout for the 3 BHK dwelling units and 2 BHK dwelling unit. This is the working drawings for the same. These are the electrical layouts for the 3 BHK floor plans. These are the electrical layout and the plumbing layout for the 2 BHK plan. These are the plumbing layouts for the 3 BHK. And this is the electrical plan and drainage plan for the whole site area. Yeah. Coming to these system selection criteria, the moving bed biological treatment system is used as an STP because of its efficient reuse of 66% of domestic water, and compared to conventional ASP or septic tanks, it requires less land and less maintenance. And the solar panels we chose are high efficient bifacial modules which can generate 413 kilowatt of energy. And coming to the solar water heaters, 36,500 liters per day is generated from the 73 heaters, and two diesel 2 diesel generators are used in this site for the power backup, and the GGBS is replaced, is 35% of the cement is replaced by GGBS. This helps in reducing the 30% of carbon reduction and also ensures the durability. For the collaborative innovation, the innovation techniques we used are solar panels, solar water heaters, low flow fixtures, and the sewage treatment plant.
Coming to the Kutira Darshini app, what we have thought is every resident should know about their home, whatever the plan, the structure, the design, and even the energy calculations. So we allowed this app to know the resident about their home, about the water calculations, energy consumption, saving, and how much they can save by using small activities that can be done in home. That app allows a resident to know how much they can save. And we have provided in the app some activities like Koutram Connect, which allows them to talk to other residents, and small quizzes which help them to actually understand their home better. You can scan the QR code there and please click the login to explore more into the app.
In health and well-being, there are 4 major components. We have calculated thermal comfort, charjas, ventilation, and passive strategies. When it comes to thermal comfort, we have considered factors like wall, windows, roofs, internal heat gain, and CFM. So we have calculated the thermal load, that is BTU per hour, and converted it to tonnage. We have calculated for the May 23rd day, which is the peak, which is the hottest day of the year. We got 0.19 tons of requirement, which could be cool with fans. And next, for charja calculations, we have considered azimuth angle and solar altitude angles, and you can observe the section there. Next slide. These are the illuminance calculations. The lux levels are sufficient. They should be ideally be between 200 and 300. We got an average of 120. Near windows, there is high lux levels, but they can be managed with blinds and curtains. In passive strategies, we consider factors like natural ventilation, landscaping, building orientation plan. And we also have, in landscaping, we have considered factors like ornamentation plants and garden plants, etc. Next. As you can observe here, the base case of energy is 75. We have offsetted it with using orientation, envelope, and openings, etc. to 18.2% EPI. In the total consumption of entire year is 11.3 lakh kilowatts, and the solar panels could generate 5.7 kilowatt per year, 5.7 lakh kilowatt per year. For active and for regarding strategies, we have used energy efficient fixtures and motion sensor based lighting and IoT systems. And when it comes to passive strategies, as I have explained below, we have designed using orientation, landscaping, etc. Next. This is solar panel plan and solar water heater plan at roof level. As you can, as per NBC guidelines, the water consumption of an average person should be 135 liters, but we have brought it down to 85 liters using energy efficient fixtures, water efficient fixtures. This is a chart of treated, this is a chart of consumption, and this is a chart of various sources. 40% of our water comes from bore, and 30% of our water comes from treated grey water, and rest comes from homespun and rainwater. 50% of our needs comes from bathing and laundry. Most of them are offsetted with treated grey water. Only for cooking and drinking purpose, we would be using fresh municipal water. Next slide. Here we can observe generation of rainwater and treated grey water and consumption of landscape water. Next slide. Here we can observe broad overview of consumption chart, and we have offsetted 60% from initial base case of water consumption using energy efficient, water efficient fixtures. Next. Regarding water treatment system, we have integrated a 5-stage process, that is MBBR system, pressure sand filter system, active carbon filters, UV disinfection units, and we also have integrated low flow fixtures.
Here is a comparison between the baseline and the proposed for carbon emissions. The baseline has brick for the wall, and we've used AAC because of its lightweight, faster construction, and less heat gain. For the windows, they've used UPVC, and we've continued the same because of the low cost when compared to wood and aluminum. And for the flooring, they've used vitrified tiles, but we've used oxide flooring because of its natural materials and traditional essence that we wanted to have in our design. And for the roof, they've used RCC, and we've put the same along with a layer of foam concrete for better insulation. For the structure, they used ready-mix concrete with OPC, while we used Portland slag cement with 25% GGBS, which emits a lot less CO2. And for the fenestrations, our emissions increase because the baseline has a lot lesser windows, and the air circulation wasn't up to the standards. So we've increased the number of openings for better air circulation and daylight.
Coming to resilience, in the past 20 years, Hyderabad has experienced a 16% growth in urbanization, which altered the city's topography and the climatic conditions, which also impacted some environmental and disaster-related challenges. Heat waves. According to IMD, a heat wave is a day where the temperature rises more than 40 degrees Celsius. So in the past 2024, there were 25 heat wave days. So in the coming years, there's a more scope of heat wave days. So for this, the strategies we implemented are tree albedo and tree cover is increased, providing atriums and courtyards, improving U value of envelope, cool roof paints during summers. Urban flooding is a critical hazard in Hyderabad due to improper drainage system, which fail to accommodate the modern urban needs. And also due to encroachment of lakes and low-lying areas. The strategies for this is elevating the ground floor by a meter, planning efficient stormwater drainage, increasing groundwater percolation. During energy crisis, the building relies on backup generators, and also the solar energy helps in by providing a sustainable solution for this. Mosquitoes and pigeons are avoided by using a scarecrow and also mosquito proofing openings. The table shows the water storage capacities in a month, and the lowest is the 6 days. Like during the crisis, we can sustain 6 days without any municipal water, and the highest is 23 days in October. Coming to the affordability, affordable flats help the buyers in making the home ownership more accessible through lower cost, and developers through high demand and government incentives. Back. The chart shows the comparative between the base case and the proposed case of construction budget. We have used AAC blocks, which has reduced rupees 1237 per cubic meter, and the slabs has reduced the cost of the skill, and the RCC slabs and beams have reduced the skill labor's cost and the depth of the slab. The built-up area has also been reduced. These two graphs shows the ROI percentage and the LCC of the water heaters, STP, and the electrical grid.
Our project aims at getting homes that use less, cost less, and feel better to live. All of these factors allow an investor and user to have advantage because of low maintenance, value for money, green and healthy environment, minimized operational cost.
Koutram is a space that brings people together, blending traditions with today's needs. It's calm, welcoming, and rooted to nature. It's not just architecture, but a place to live, learn, and connect. Thank you.
Thank you, team. You gave a very insightful presentation. Let's hear the jury comments and take questions from them. Who wants to start?
Okay. All right. So, when I saw your report, so first of all, congratulations for making it to this stage. I saw your report and I really liked your visual storytelling in the report. And I was looking forward to your presentation. But I think you did far too much of like copy pasting tables and text into your presentation. And I'm sure there were like some constraints around time or that kind of thing. But I think in terms of the visual storytelling, this was probably the best report that I reviewed. The solar panels efficiency that you mentioned, is it a product available on the market?
Yes, sir, it's available in the market.
Okay. Can
It's
we...
40% efficiency.
How much efficiency?
40.
40%. And what are the economics of that?
I'll get this.
Have you considered that cost in the...
Yeah, yes, sir. We have considered the solar panel cost in the calculations.
Okay. So what make are the panels?
So these are the panels, as you can see. Each can produce 700 units, and 70% of the roof area has been utilized for solar panels.
Okay. And these are available commercially in the market?
Yes, sir. These are available commercially in the market.
I think they've said Loom Solar. Okay. Who did you talk to
We have
about these?
we have spoke with few industry professionals. Actually, it's an academic problem for us, so we have spoke with jurors, etc.
Did you speak to the supplier?
Not in particular. We have checked their website and.
Okay. Maybe. I mean, yeah. Also, you mentioned something that 0.19 tons of air conditioning. What was that for? I didn't catch that.
Yes. So generally, when we are cooling something, we are cooling tonnage, right? Like if there is 5-ton requirement, we'll keep a 5-ton AC, etc. So we calculated the heat gain in the building.
Okay.
So based on it, we got 0.19 tons in peak day of summer.
For?
Peak day of summer, that is May 22.
For what? Like 0.19 tons for what space?
Bedrooms, bedrooms.
Okay, so then what do you do with that?
It can be ideally cooled using fans only, sir. So there is no need of AC requirement. That's what we want to say.
Okay. There was a slide that you had that on. Can we look at that slide
yes.
quickly? Yeah, the one before that. The one just before that. Okay. So I think your assertion was that since it's only 0.19 tons per bedroom, you don't need
Yes, sir. We don't
air
need-
conditioning.
Yes, sir.
And you ran that through the thermal comfort analysis.
We actually did it through calculation, sir. We have confirmed it through few ECBC experts, etc. This calculation.
Okay. In terms of the cost, what was the baseline definition for the cost?
The baseline is what the project partner's design was.
Because you said you had some increase with the number of windows.
Yes, sir.
So that just made me curious about like what was the baseline, like how much did you increase the windows, and so this is more of like a curious question than anything.
So before the baseline had way less windows and without proper ventilation and air circulation.
So they had a design in place already, is it?
Yes.
Okay.
But now we've checked what the baseline was and we've calculated, and then we've put the wall window ratio to 20% for ideal, like we've calculated during winter and summer. So the ideal for our design was 20%, so we've stuck with that.
Okay. And you mentioned heat wave days. Can you go to where you mentioned the heat wave days? So 10 to 30. So you're going to have like night flushing and ventilation, increasing tree albedo, tree cover, atrium and courtyard. And this will reduce the heat wave days.
And also the self-shading, if you see our blocks, they are clustered. So the self-shading also reduces the urban heat effect.
Okay. But what, any quantification for this?
We did when we announced.
We did wind analysis, sir. We got 0.6 meters per second wind ideally.
Okay. All right. I think I'll give it to my fellow jurors.
Yeah, I'll concur with Alok's point. I think whoever is the graphic designer in your team, that person needs to be called out separately and appreciated separately. Very nicely done. It's in your team or was it outsourced? Oh, you did it. Very nicely done. Yeah. Now, a couple of questions. So, first on continuing on that 40% efficiency point. So, was it the peak efficiency or the average efficiency for that solar panel?
It's average, sir.
Average. So, what's the peak going to?
It's going to be 45, somewhere like that.
So, if 40 is the average and 45 is the peak, then you are around the peak at
Yeah,
most
yes,
of the
sir.
time.
We are close to peak.
But then, if I look at the movement of the sun, you will not have that much irradiation in the correct angle throughout the day.
Yeah, yes, sir. When it comes to calculation of days, we have considered only 300 days in a year, so that we wouldn't consider any rainy days, and we have considered only peak hours, that is 8 hours, etc.
No, but even in those 8 hours, the sun is going to have its
Yeah, yes, sir.
orbit, for the lack of better word, and the angle of irradiation is going to go from the minimum to peak and then again
Yeah, yes,
to the
sir.
minimum. So I think it's hard to believe that you will have average of 40% efficiency by taking into account the angle of irradiation.
Okay, okay.
So please look into that.
Yes, sir.
Second, you are not utilizing the full FSI. I think in affordability, one point you mentioned was that you have reduced the built-up area. Is this acceptable to your project partner?
Like we had a pitch to him that the and our project partner's design was going into the setback, so they had a more built up area than us, but we have reduced it because the people who are coming to Bachpally are like first time buyers and they're migrating from villages and here, so at first they won't be able to invest in a house which is a luxurious, rather than they might choose this. And also
But luxury is not correlated to utilizing the full FSI, right? You can have a project cater to the LIG segment also that utilizes the full FSI. The builder purchased the land at a particular rate and that money is gone. The land is purchased. So by reducing FSI, the ROI on that investment is being reduced, right?
yes sir, but there is a quick buying, maybe the sales are faster.
No, please. Have you discussed this with your project partner?
Yes sir, like
And-
we gave him a pitch that like some of the news articles says that there's a 9% decrease in average flat area, and this is preferred because the people are more into buying them.
The average flat area can be lower, but the number of flats could have been higher. You could have still utilized the full FSI.
Okay.
Yeah, think about it. Yeah, thank you.
Can you go to the health and well-being slide of yours, please? Yeah, the one before. Right. So here you're saying that your source from Terry says that the minimum required for workshops, stairs, etc. is about 100 and normal homework sustained reading is at 150. Okay. And as I see, you've done the analysis for a particular apartment. It'll be interesting to understand that out of, that block A that you have, which apartment have you picked up for doing this analysis?
This one is for the third floor, ma'am, and it is the
No,
central.
which block out of that? You can be on that slide.
These two.
You've
because
picked
they
up
are
the
in
inner two
central-
blocks.
Yeah.
Blocks. Can you go back to that slide again? So as you can see here, almost 70-80% of your area is around that 17 mark, right? It's like totally pitch dark. So do you think that it is possible and it is healthy and it is good for a person to live in this kind of lack of sunlight environment?
This is 121, and like the major part.
It's between 17 to 100, most of it.
Yes, ma'am. And like if you see the bedrooms area, like the bedrooms or reading rooms are of like.
So your toilets, utility, your living areas, except for little fleeting corners, there is hardly any sunlight, and it is very obvious because you can see the massing in your model, and you can see that inner about 4-5 blocks literally get no sunlight throughout the day, throughout the year. So in that kind of circumstances, I'm not sure. So while it is important to have shading and energy efficiency, all of that, please understand that sun has its own advantages as well. There is a reason we are alive here is because of the sun. Okay, so the sun is very, very important for health and well-being of human beings, right? Whether it is human beings, whether your courtyards have, plants, whatever it is, without sunlight, none of them can survive. The reason there is life on earth is because of sunlight, right? So in the ambition of trying to make it energy efficient and reducing heat gain, we should not pass the barrier of understanding the importance of sunlight. So I think your massing of the project, while you really started off very well with the Koutram concept, and like both Yash and Alok have said, that when we started off with the presentation, it was really nice. You were one of the teams who brought in that Indianness and that local context and concept. But however, when you pushed it too hard in the ambition of bringing that courtyard into really making these clusters, which I'm in for lack of any other word, it's kind of a slum development that you've created. And while you're trying to do low cost housing, it is not necessary that you create a slum development, right? And the wind analysis also, if you go back, you will see the way you've drawn out. I'm sure it's not out of a software, because the way you've done the wind analysis, there was a diagram before. You've literally drawn your arrows as if, the wind had a mind of its own, or they were AI enabled. So the wind is not going to be able to flow like that. They'll hit against that 10-story wall and come back. So there's no way the wind and sunlight will get into your block A. I understand that the other two blocks will have enough amount of sunlight and all of that. However, one of the sides has extreme heat because of the west facade, and you have justified that with enough amount of fenestrations, and maybe you can take balconies and all of those things. But I have not seen with you, and I have not seen with anybody, there are very easy low cost methods of creating double walls, etc., where heat gain can be reduced. You need not make clusters like this. You have to let the sunlight come in. Essentially the east sun, to some extent the south sun, that is healthy, good sun. Please let it come in. It is important for life and living. After that, where there is west sun, there are numerous ways to try to dissuade the heat gain. Right, that will be my only comment on the massing. Rest of it, you started off with a very good concept. I wish you had taken it forward in a more effective manner. Thank you.
Thank you.
Thank you, jury members. Thank you, Team Kutiram. Let's take 5 minutes and get ready for the next presentation. Our sixth presentation is Team Parami. They have worked on a project called Mahindra Vasudha and it is located in Bangalore.
Good afternoon. Hello, hello. Good afternoon, everyone. We are Team Pargami. I'm Himanshu Agrawal. This is my teammates Maulidhar, Sriniti, and Akshat. So, our project is called Mahindra Vasudha. We are from School of Planning and Architecture, partnered with IIT Tirupati and Adani University. So, our team, it is a multidisciplinary team comprised of architects with specialization in sustainability, landscape, and engineers with specialization in structures and environment. And we have Mahindra Life Spaces as our project partner and EcoSTP and Ambiator as our industry partner. So the question is, what if? What if your home could do more than just shelter you? It could heal the city, it cool the streets, it could teach the next generation. So as we know, Bangalore, it's going under rapid urbanization. So that have problem with the heat waves, water shortage, and unaffordable living. So we have a solution. It's called Mahindra Vasudha. So as from our project partner, we were provided with a brief for this project located near Manipal County. It is a site of 2.3 acres, from which we have got a brief to make 3.5, and 4 BHK. That consists of, and our project is consists of 3 towers with amenities, co-working spaces, outdoor playing area, multi-purpose hall, and various other amenities.
We have utilized FAR of 2.94 out of 3.25, focusing on comfort, daylighting, and open space over maximizing out the total built-up area. So it meets all the basic design requirements and also benefits the contractor. In the aspect of reducing total construction cost, improving execution timeline, and also enhancing market appeal through better living quality. So the climate is largely comfortable throughout the year. So with a mild hot condition in the span of March to May, with a peak of 34 degrees Celsius. So the predominant wind direction is east and west, which has guided us to place the livable spaces along these facade to enhance the natural cross ventilation. So the form development. So we developed the built form through multiple design iterations, and based on wind study and shading analysis, the blocks are oriented north-south oriented to reduce the heat gain and also to enhance the wind flow between the towers. So vertical zoning. So in the vertical zoning, we have separated the spaces as services, amenities, and living areas. So placing parking at the below, along with the services and the community spaces at the podium level, and above the living areas, which has access to the light, air, and privacy. So alternative unit floor plan has been utilized to enhance natural view and ventilation, promoting a more nature integrated design. So this is ground floor silt floor plan. So the ground level silt enhance smooth access around the site with 3 separate core dedicated visitors parking and drop-off zones. So a 16-meter of setback on all sides, along with open still area and green buffers, enhance ventilations and circulations and landscape integrations into the site. This is the basement floor plan, which has the parking space with which has visible access, and it has all the services within the base. The steel floor plan is an superstructure parking areas to accommodate all the parking requirements of the project. The podium level. So the podium level is designed as a active community space beneath the mutual shaded of the towers. So these spaces provide promote interaction in a cooler, comfortable environment, and integrating landscape element enhance pedestrian experience and encourage social interactions. So it is a typical tower unit floor plan, and is designed followed by Vastu principles, aligning entry points, kitchens, and bedrooms with cardinal direction, and also focusing on human-centric layout for user comfort. A balanced floor matrix with 2 to 3 units in a tower, and maintaining efficient circulation, privacy, and optimal density across the tower. So these are the architectural drawing of the tower units. So the layout shows typical and alternative floor plan of towers 1, 2, and 3 with 3, 3.5, and 4 BHK units. So these are all the livable spaces are typically placed along the periphery of the plan to enhance the cross ventilation of the space, while balconies are utilized as a buffer space, which restricts the direct heat gain access infiltration inside the space. So which would reduce the heat gain, and also additionally the internal floor partitions are customizable based on the user needs. It's a service floor plan which integrates all the utilities, water tanks, and refuge areas at every seventh floor and staff recreation zones. The height of its height of 2.45 meter and complies with the building bylaws level, ensuring FAR guidelines. It's a terrace floor layout showcasing the utilization of the solar panel coverage area, and thoughtfully locating the wind turbine location to for the optimal energy generation, renewable energy generation. This design supports sustainable energy goals while maintaining functional rooftop design access. It's a sectional elevation illustrating the vertical zoning of the towers, and highlighting services flow and integration of the bamboo facade treatment, and overall structure height of 71 meters across the 24 floors. See, the overall design compliance by the bylaws, regulations,
Can I just interrupt 1 minute? Sorry. Can we get to the 10 contexts?
All the 10 contexts.
Which is it seems more like an architectural design presentation.
No, we do have that.
Go quickly on this and stick to the
Coming to the landscape, we have used the principle of Vastu Shastra in the landscape also. Vastu Shastra tells us about the different colors in the different direction of water, air, earth, and fire. So I've done the different level of landscaping, that is a lower level, the shrub level. This is the upper level with the trees layout, and then these are the views of the building. So we set the goal for the each constraint and we have achieved it. These are the structural detail in.
The structural detailing was done by referring to different IS codes. The first one here shows the sectional drawing of a beam. The second one here is a plan view of the raft footing that we are using for one of the units of the buildings, which is unit 5. This is the layout of stirrups which are provided, and this is the sectional view of the footing which is represented in the above picture. This is the slab design, and the assignment of loads was done using IS 875, and the additional load for solar panels and other fittings were also considered along with the dead loads. The maximum laterals we observed in the building was 130 mm, which was within the permissible limits. And composite columns were used to reduce the dimensions of the column and hence reduce the concrete quantity used. These are the analysis results obtained. This is the final simulation that we ran in ETAP software, and this is the laterals we observed in the 2 directions.
So coming to the solid waste management system, we are segregating the waste at the early stage of the waste collection. And similarly, for the organic waste, we have a biogas plant on site. We are processing it, and we are not using the biogas on site. We are selling it as later on the later stage. 80% of the waste diverted through composting, biogas, and circular use. So coming to the innovation, so we took care of all the stakeholders throughout the design process, construction, and the post-occupancy. So starting from the project partner, we got the brief for the nature therapy living for Vastu compliant. And we took the support from the industry partner, that is Ambiator and Eco STP, to have the energy efficient and sustainable HVAC system, and the STP that works on the principle of sustainability. Then this is the detail of Ambiator. Why we chose Ambiator is because it was performing better than the district cooling, VRF system, and radiant cooling. We had the comparison, we ran the simulation in the different HVAC systems, and it was very energy efficient while comparison to others. Same Eco STP that mimics the cow's stomach, and it doesn't use electricity and no chemicals. It works on the gravitational flow of the water. And to have the live tracking of all the resources, energy, carbon, and water, we have the building operational lab that rewards the residents if they save the energy and water. Similarly, they teach the occupants how to use the net zero building, because if we build it and if we don't do it properly, then it is not a sustainable building.
So for the daylighting, we have focused on optimizing the daylighting access by providing optimized window wall ratio, and also by providing shading devices like as an pivoted use of pivotal windows and integrated BIPV panels which are adjustable. So this allows natural ventilation as well as increase the daylight spread. And this iteration has been taken from a different level of the buildings. So in order to provide shading strategies for those levels. So these are the iterations that we did, and in order to increase the base case iteration. So this operating temperature, so in a mixed mode southwest facing units, we have compared conventional bricks construction wall assembly with an enhanced AAC block with use of XPS insulation. When the enhanced wall assembly used, there was a significant drop of 3.8 degrees operating temperature in those southwest corners facing spaces. And also it lies within the Bangalore IMAX standard. So as for the landscape, so we have utilized landscape strategies in order to engage the community activities, also to improve the air quality and increase So the outdoor thermal comfort. So it has been done done by EnviMet by use of vertical gardening and pedestrian level vegetations, which combined shading and evapotranspiration effect, which has lead to a reduction in the 2 degrees Celsius temperature, and these vegetation creates a passive cooling effect and improves the thermal comfort of the pedestrian.
So coming to the energy part, with solar rooftop facades, parking shades, and wind turbines, we achieved the 19% of the net positive building. So we took care of the occupants' behavior, because as we know, occupants' behaviors is volatile. So in future, if the efficiency of the different appliances decreases or the occupants' behavior changes, so we are net positive. So we can take care in the future. It might be the net positive. It will be the net zero building. So throughout the various iteration, we modeled with the different material, with the different wall and roof assemblies, and different HVAC systems with different BE rated appliances. So finally, we achieved 24.3 EPI, kilowatt hour per meter square per year.
So for water, we followed three major strategies. One was the demand reduction, then we conserved rainwater, and the third was we treated all the water which was generated on site, which is the black and the gray water. And we have used ambienter cooling system, which uses water for its cooling. Since it is a scarce place, we have used all our wastewater treatment, treated water to service the ambienter. So as we already mentioned, the EPA has been greatly reduced by using ambienter. So we weighed the cons against the pros of ambienter. And we have, so Eco STP water is further disinfected using a ozonizer, and then that water is used for the ambienter. So we have achieved an overall water positive cycle within the site by using recycled water and rainwater harvesting. So we have located our overhead tanks on 3 locations, that is the 2 service floors and the terrace, to distribute the weight and to reduce the sizing of water tanks on the terrace floor. And we have provided the dimensions of those tanks over here. And the underground tank has a 3-day supply of water, which can be used in case of any power outage or anything. That view shows the section of how the OHT is present over here, and then the solar panels are fixed above the OHT. We have also worked on overall reduction in embodied carbon. This is done by usage of materials as well as through design. So we have replaced some of the basement parking from the base case by using podium level parking, and by giving only one basement level parking. And we have also replaced some of the conventional materials by using green cement. And there is also some existing structures on our site which we have reused in our construction. So on our site, we are going to sort out the materials which are there, and we are going to reuse it. And by using that, we achieved a small carbon reduction. And we have also used carbon negative materials, which is bamboo facade. And then we have also used the carbon craft floor tiles, which is helps in carbon sequestration. And this is our baseline for the, and this is the proposed case for our embodied carbon calculations. So overall, we were able to achieve a 75.5% reduction in embodied carbon. And this is the final selection of the materials which were used. This is a section of the wall and the roof construction which we have used, and this is the carbon craft floor tiles. So this is actually made out of air pollution, and it helps in reducing the embodied carbon because it uses the waste product from tire industry.
So coming to the resilience, first we divided the resilience into 6 parts: the human resilience, social resilience, economic, institutional, environmental, and physical resilience. And we tried to mitigate it by using different strategies at different level.
These are the different calculations involved in the project cost estimation. These different parameters are also compared for the baseline case and the proposed design case. For a better visual representation, we can refer to this chart. And this chart here represents the payback period of the solar PV cells, which is around 6 years. Now coming to the savings in the design part, our passive cooling and water efficient fixtures and solar PV cells slightly raise the capex costs, but they reduce the opex cost in the long term. In construction phase, we are using recycled materials, and water harvesting systems are also taking money, so they are sort of balanced in the capex. But these strategies reduce the operational costs and hence reduce the opex. Post occupancy phase, we are using smart systems and efficient appliances. Those reduce the capex and those do not reduce the capex. They have a slightly higher capex and they reduce the opex in long term. Hence, the affordability is reached. Our building has a high performance passive design and a net zero water and resource efficiency. We are also renting out spaces to community and selling the produced biogas from waste. This can reduce the maintenance cost to the people who are residing in the buildings. These are the facilities provided in our buildings: urban farming, gyms, community spaces, EV charging spots, etc. And hence the value proposition was also achieved.
So this is a continuation from the movie. So Mahindra Vasudha is a collective response to urban uncertainty, a living system that cools, cleans, and connect. Thank you so much.
Thank you, team. You did a great job. Let's hear the jury comments and take questions from them.
Hi, a lot of hard work. You've done a good job, good presentation, covered most of the points. Since you are claiming it to be a net zero project, could you go back to the slide where you're showing the solar output? And you have solar panels only on the terraces, right?
Ma'am, terrace, facade, and the shading devices also.
Where on the facade are you taking? Didn't see that in the
Ma'am,
elevations.
from 15 to 24th floor. Because in the lower floors we were not getting much solar exposure. We did a solar radiation
I understand that, but in the elevation, where are you taking it? Can you show that?
So, ma'am, similarly, like here, this is a shading device that is equipped with the solar panel. So it is a mechanically operated device, and we can adjust it. Similarly, in the walls where the windows are not there, from 15 to 24th floor on the southern side, we are placing the.
So all the south walls you are
Yes.
taking. So can you go to the site layout? Where your building blocks are visible.
Yes, ma'am.
Yeah. So essentially, you guys don't put a north sign in architectural layout plans. In your architectural colleges, I'm sure they insist on that, right?
Sorry.
So if you can please tell me what is your north direction?
Upwards.
It's upward. So you basically have like 1, 2, and 3 units which have a solar possibility on the wall.
Yes,
So it's these 3 units on the top floors.
It's actually on unit 4. Unit 4, 6, and 7, and also in unit 1 and 2, it's above the 15th floor. It's the south facade is exposed to this.
You have a height difference?
Yes, ma'am. So
Okay.
the units 6 and 7 are 11 floor heights. So rest of
Understood.
the floors are 23 floors.
So what is the solar area that you have on the facade, and how much do you have on the roof, and what is the kind of efficiencies that you've taken?
So, ma'am, we have taken the efficiency for the for wall. We have taken the 60% efficiency for the solar panel, and for roof, we are taking the 92% efficiency.
Yeah, I mean, what is your definition of efficiency?
Ma'am, because of the solar incident that is coming through the wall and the roof. That's why, because
I'm not sure you understand that in the industry, there is the highest efficiency solar panels around 20, 22, 25, 28 max. Okay. So I'm not sure what your 94% means.
94% is in the aspect of generation. So we have a reduction few percentage in aspect of loss factor. So the
potential generation.
Oh, okay.
So, and to answer your questions, the efficiency of the solar rooftop panel are between 20 to 25%, and the BIPV panel are 10 to 15%.
Okay, that's what I was asking. So basis that you are able to generate enough energy to offset your. Okay, that was my question.
Ma'am, actually it is a 90. It is a net positive 19%.
You've answered my question. No worries. My second question was regarding your composite columns. You are taking MS columns and then cladding it, etc. In a residential format, how does that work? What's the finishing internally for those columns?
Ma'am, we actually referred to IS 11385, which talks about composite columns, and it was revised in 2022. So we have referred to that, and in this, it is basically used for reducing dimensions.
I
And
understand that. My question is related to interior finishes for the user.
sorry.
My question is related to internal usage, the finishing. How are you, what are you doing to the composite columns? You have an MS inside. Are you cladding it or are you concreting it? What is it? What
Yeah,
do you
we are
mean by-
concreting it. So it
So
is
it's-
basically encased by the concrete that we are using.
Right. So if you are encasing it, how? That's what I want to
So,
understand.
we put the formwork, then we put the layout of the steel rebars that are provided, then we put the I section, and then we pour the concrete.
Right. And then you're removing the shuttering. Is that what you're saying? All right. Because in a residential format, if you have MS exposed surfaces, it's very difficult to use that facility, right? Yeah, that's really it. My last question was that you have mentioned Eco STP. Can you show us on your layout what is the space that you've given and what's the output calculated?
So actually, ma'am, here we can see the Eco STP layout. We consulted with the Eco STP experts, and they have given us the area. Previously, we were going just to recycle the gray water, but we went with the gray water plus black water, and they suggested at the area, because it was a 10% reduction, 10% addition in the area if we are treating black and gray water both. So it is. Yes. The plan and section provided by the.
And you are able to service all these families with flushing water or whatever water you're using that STP water for. And because you've claimed net zero water as well, right? Not only net zero energy.
Yeah.
Are
so,
you?
Yeah, so fresh water we cannot provide with this. So, but all the flushing and the landscape requirements are covered by this. Freshing we are still taking from municipal, but the amount of water we are returning to
yes,
source is
you
more
are
than that.
net zero discharge.
Yes.
That's
but,
what you're
But
claiming.
we have a water performance rating of 46, which is less because we need fresh water for usage.
Correct. So that is not net zero water.
Yeah.
Just clarify.
Yeah,
that.
yeah.
Great. Thank you.
Thank you.
Nice presentation. Just that initial hiccup of too many slides on architectural drawings, but I think you have covered everything well in time. The same question as the previous team. You are not utilizing the full FSI. Have you spoken to your project partner about it?
Yes, actually, we have spoken to the project partners regarding this. Like, we were provided with a brief of number of units and all the amenities that needed to be provided. But based on the site constraints, bylaws, and all the setbacks, we had a minor area where also the height restrictions we need to follow. So, and also in order to achieve comfort, natural lighting, daylighting, so the build form should be an access to, it should be an open form and access. We can increase the FSI. It would increase the project value in the aspect of the contractor, but it will create a question mark in the aspect of comfort.
So
But
what?
also
So what
in the
did the
existing-
project partner say? Are they agreeing to this or not?
So in the end, we are increasing the comfort of the users. So by emphasizing on that, we can increase the value of the units. On that basis, we can generate more income for in the contract aspect.
So against 3.25, you are at 2.94, right?
Yes, sir.
So that's an estimated reduction of 10%. So do you think you will be able to justify a 10% higher value of each flat compared to what a user would originally pay?
Sir, actually we iterated, we designed with the more FSI also. And then we ran the simulation. We were not getting adequate sunlight because we have already achieved the maximum height. We are near the maximum height.
I understand why you chose the low FSI. I am just asking whether the partner will agree to it.
Sir, I think according to the facilities and the value proposition that we are providing with the comfort and health and well-being, they
Everything
will
is
be-
for the end user, not for the partner. Why will the partner agree to it?
Sir, obviously, if we are providing all this facility, uh, the the prices uh, of the individual units will go high.
So 10% is your target, and when you speak to your project partner, that's what you have to justify.
Yes.
That the price will be 10% higher than the market price. Second thing about the 19% surplus energy that you have.
Yes, sir.
What are you doing with it?
Sir, actually, it is not that we are having the batteries and taking all the energy on the site. So the solar and everything is connected to the grid, and we are taking the energy from the grid, but we are providing it with the surplus energy. So we don't have an energy bill,
So
electricity
your
bill.
solar panels will not power the households directly.
On the time of disaster, it will be it have a relay, so it will be directly powering the building. But on a normal day, it is connected to the grid. We are giving back to the grid, and we are taking because and also as it is a 19% surplus energy that we are producing. So as I mentioned, it works on the volatile behavior of the occupants. So it might decrease in future with the decrease in the reduce in the efficiency of the appliances that are used inside. Also the solar panel, because it also reduce the efficiency.
Okay, so you are giving it directly to the grid, and some part of it will be used, or rather, it will be used for household appliances during disaster.
Yes.
At the time of disaster, will the solar panels be able to meet all the requirements?
For UPS system, sir, it is directly connected to the wind turbine that we have.
Wind turbines, will they be able to meet all the requirements?
For the emergency lighting and purposes, it will be able to meet it. Not for all the comfort, but for the emergency purpose, it will be able to make it. If we have a blackout in the city, then we can use it.
So solar panels are still not used for.
Sir, if it like on daytime, we can use it. We have a relay. We can switch it to the building and switch back to the grid if you want. And at the night time, we will be utilizing the wind turbine. On daytime, we can utilize the solar panels.
Why not have some batteries or some storage on the side?
We have a backup for resilience, but the further resilience, we have provided this services. There'll be backup for the 3 days
Okay.
for the building.
Okay.
Thank you, sir.
Yeah, so when I looked at the reports, I thought this was the most rigorous, well-integrated project.
Thank you, sir.
But you did not do yourselves any favors by going on about layouts for 7 minutes. And I think that, so I have a few questions. One was, I don't see wall sections about the wall panels for BIPV, because you're talking about some plaster and such in the wall section. So it does not check out in my mind. I also saw in one of the renderings you had a V8 vertical axis wind turbine on top of the solar panels in one of the illustrations. And then on another illustration where you're showing the overhead tank, you're showing the vertical axis wind turbines are not there. So that to me felt like a little bit of a...
Sir, actually, these are the water tanks and these are the wind turbines that are placed around it. It's not at place at the same.
But if you go to the other where you show the vertical axis wind turbines, yeah, good. You're showing the vertical
Sir,
axis
this is the
wind.
product that we are using, Windstream.
Okay. So this is not a rendering of your.
No, sir, this is not.
Thank God.
Because we first went with the Aeromine, that is the London-based company, but we could not
Okay.
import it,
All
so
right.
we used the
Okay. Have you incorporated the BIPV costs into your cost analysis?
Yes. Detailed the Excel that we have provided. It is.
No, it's okay. We don't have time for that. We are running over time. But I want you to repeat after me. Okay? And maybe everybody in this room should repeat after me. A manufactured construction material
Manufactured construction material
cannot be negative embodied carbon.
cannot be negative embodied carbon.
Okay? Think about it, analyze it, look deeply at the LCAs of manufactured construction materials. But this perpetuation of this myth that a manufactured construction material can be negative embodied carbon or sequester carbon, it's paid nahi hai wo. Right? So I think healthy skepticism and sometimes maybe even like militant skepticism. And you had very good slides for goals and your targets, but you just did not give us a chance to even look at it. Matlab, one blink and it's gone. Those were your headline indicators, right? That was your like success kind of indicators. And everywhere you had those goals and targets achieved, you were not even letting us look at it. You're like, so it makes me wonder, like, chal kya raha hai? Like, you did not want us to like absorb the fact that you've done so well, or like kuch gadbad hai numbers mein. Okay. I loved the fact that you started with the what if. But when you start with a what if, then you need to continue in a storytelling manner. What is and what can be, what is and what can be, right? Which I think you kind of did not give yourselves the room to do. Okay. Thank you.
Thank you so much, sir.
Thank you, jury members. Thank you, Team Parami. Let's take 5 minutes and get ready for the next presentation. Our last and final presentation is from Team Astitwa. They have worked on a project called Mahindra Cascade, which is located in Whitefield, Bangalore.
Vasudeva Kutumbakam. The world is a family, and every family deserves a home that nurtures, heals, and sustains. Bengaluru, India's IT capital, built on innovation driven by its professional, but what powers them? Behind every system update is a person overworked, undersupported, and seeking balance. Meanwhile, the city faces flooding, drought, and green cover erosion, especially in the regions of Kadugodi. Good afternoon, everyone. We are Team Astitwa from BMS College of Architecture, Design and Planning, partnered with Mahindra Life Spaces and presenting before you Mahindra Cascade, a project that offers home for our digital builders to breathe. A site is located in Hope Farm Channasandra, Bengaluru, and spans over 9.6 acres of land. In the immediate vicinity, we have Hope Farm Channasandra metro station and a metro yard. The site is located in a temperate zone, and the average annual temperature is between 19 to 28 degrees Celsius, and the prevalent winds are east-west winds. After a thorough climatic analysis, we studied the wind patterns, sun path, and comfort analysis, which helped us come up with the final design, form, and passive strategies. So we have used 100% of our FAR, and our total built-up area is 122,000. So after several design iterations, based on the climatic simulations, we have arrived to this final form. So we have come up with a linear form with central courtyard spaces, and we have provided aerodynamic voids, which analyzes the east-west winds. We have also played with levels, segregating the 3-4 BHK in one component, 1-2 BHK in another component. So we did a climatic simulation ensuring each unit is well ventilated and lit based on the aerodynamic spaces which we have provided in between the units. So the residential building is divided into 7 towers with central courtyard spaces, which sits on a podium parking. So the design strategies which we implemented was a self-shading form and utilizing the H-core for space optimization. And we spent quite a bit of time in ensuring each unit is well ventilated, either through windows or through the balcony spaces. These are the different typology of units which we are offering to the different user groups. So this view explains our entire design with the residential units, the podium parking with clubhouse spaces, and also the sports facilities and a swimming pool behind the clubhouse. The automated operations include energy management system, which optimizes the lighting and ventilation, automated awning windows, which operate based on the rain and heat, a smart meter, which enables the user to track their real-time usage, a humidity sensor, operable vertical fins, and sensory-based lighting. So we right-size these systems, and based on the soil profile, we came up with a pile draft foundation and other structural solutions. So we have integrated 100% landfill diversion, and we have also included smart chutes for waste segregation in the floor level.
So moving on to strategies, we are looking at collaborative innovation in 4 different aspects. For energy generation on site, to reduce heat gain, for wastewater treatment, and effective operations. So in collaboration with Kama Flywheel, in order to address the energy generation on site, we are introducing a flywheel generator in collaboration with Kama Flywheel, solar power plant, a biogas plant. For reduction of heat gain, we are optimizing the facade. For wastewater treatment, we are incorporating eco STP that works based on anaerobic digestion. That is an anaerobic digester which works based on a cow digestion system and hence requires no energy, cutting down the cost. For effective operations, we have proposed an app which not only educates users about their consumption, but also educates about the effective appliances and tracks their daily energy consumptions, which they can share with other users, more like a streak or something. And they also this is also helpful in automation of the building and setting user preferences. So moving on to health and well-being. Where with temperatures rising up to 35 degrees Celsius, maintaining thermal comfort was kind of challenging, and with natural ventilation only providing comfort for 33% of the house, exploring different types of passive strategies became more important. So we've incorporated terracotta lattice in the balconies. These lattices compress the air coming in, making the spaces inside cooler. So during summers, these terracotta lattices enable evaporative cooling, where the water evaporation, absorbs the latent heat, and hence making the air coming in cooler. So this is one of the prototype that we have tested, where this system is also automated, where the water is pumped during the high temperatures during the summers, and it is shut down during monsoon seasons when the humidity is higher. So we've also provided, based on user preferences, a different design for the same, where people can add planters on their balconies, which not only enhances the aesthetics but also improves the air quality. So for all the balconies facing the directions where the heat is more, we have provided pivotable bamboo fins, which can be slid to one side when they want to use the space, or when they want to open the space up. So based on azimuth angles. So based on for windows, we've incorporated operable fins based on simulations of the 30% window wall ratio with 0.75 overhang chaja has been achieved based on simulations, local bylaws, and thermal requirements. So these operable fins cut down the heat and glare on west-northwest, south-southwest, and east-southeast facades. Also, these accurate system around the windows add on to the passive strategy. So other passive strategies are the form and orientation, which was chosen based on the most efficient direction, which with the lowest radiation achieving surfaces. And another strategy was facade voids. These voids not only enable better ventilation and air movement, but also can be used for these spaces can be used as space for work, green, or community spaces. And so because we were trying to mitigate the use of HVAC, it kind of became important to check out the operative temperature, which we kind of did it in Design Builder. And we achieved a range of 21.9 degrees Celsius in December to 31.2 degree in May, the highest temperature, without the use of mechanical ventilation. Coming to natural ventilation, using CFD analysis, we've tested our natural ventilation, and we've achieved 0.5 meter to 1.5 meter per second wind velocity, enabling thermal comfort. And for humidity, because of the evaporative cooling, sensor-based evaporative cooling, it ensures that there's no much humidity entering inside, and the 30% window wall ratio also ensures there's no much added humidity. Coming to performance of the building, energy performance, our major objective was to reduce the energy consumption of the use phase and provide more value to the customers. In order to check out the energy conservation methods, first we've considered a flat on the southwest-most facade for the worst case scenario, which kind of projected an EPI of 42 kilowatt hour per meter square and an operative temperature of 3.4 to 5 degrees Celsius, hotter than the comfort operative temperature. So optimizing the wall with 10 mm of insulation and paint on external surface with SRI paints, we've achieved a reduction of 60 to 75% of discomfort and a new value of 1.08. Similarly, for roof, where EPI of 47 kilowatt per hour was projected, to counteract that, we have proposed a green roof assembly. which almost brought the same level of comfort as other floors. So based on all these strategies and efficient equipment, we have achieved an EPI of 19.7 kilowatt hour per meter square per year.
Coming to energy generation potential on site, we have tried to achieve around 99 million kilowatt hour per year, which includes solar, flywheel, and the biogas plant. Then coming to the flywheel requires an input which comes from the solar energy, and then the heat pump. The heating water requires a lot of energy in residential buildings, so we coped up with solar heat pumps. Coming to flywheel, it basically converts rotational energy into electrical energy. So an input of 10 minutes rotates the flywheel for 25 minutes. So the 15 minutes buffer that we are playing, that we'll be generating electricity, is taken into consideration. That is because of the weight of the wheels and the number of wheels. Each wheel weighs around 22 tons, and there are 22 number of wheels in the flywheel. Then coming to biogas plant, it utilizes a total waste of 2,716 kg per day, which annually generates around 3.5 lakh kilowatt hour per year. Then coming to energy performance, we have our baseline EPI, our baseline usage was 43.3 kilowatt hour per year, which was reduced to 24.06 with by various other energy efficient methods. So then for that, the additional cost came up to around 356 lakhs. But our operational, which is like 0.04% of the building construction value. So that operations cost is around, but the operation cost savings are around 164 lakhs per year, which has a payback period of just 2.1 years. Then coming to water, we have the number of residents that we'll be having is around 3,670. So the water consumption per day is 3,24,000. So we reduce the water consumption by using low flow fixtures from 135 liters per head to 96.7 liters per head. This shows the water cycle of our building, where the water from rain and other gray and black water, how is it circulated through the building. We are using an Eco STP where the gray water and the black water is treated and sent back for usage. Gray water can be directly used for irrigation, or it can be treated and used for other purposes, as similar to this digestive system of, this works on the basis of similar to a digestive system of a cow. This is the water balance. The numbers vary depending on the rainfall of every month. So then coming to the water recharge system, like we know, Bangalore is known for its floods. So sending the amount of rainfall that we receive, it's very important to harvest it also. So we are almost harvesting 104,000 liters of water, and we're just withdrawing 82,000 liters of water. So our complete water autonomy is 20 days with a water performance ratio of 0.97 and water back to source of 1.26. Which are great, according to IGBC standards, we are net water positive. Coming to the carbon, embodied carbon, we are able to achieve 76.54% reduction by using different design considerations and materials. First is a hedge-cross section where there are common partition walls, so the amount of blocks are reduced, the amount of carbon-emitting substances are reduced. The second would be the second one is materials locally available, like agrocrete blocks, and then we are using charcrete as the mortar. Method of construction, instead of going with My1 construction, we are using block work, which basically reduces the amount of carbon emitting substances. And we are doing on-site manufacturing of the blocks, which reduces the carbon, embodied carbon from transportation. We have proposed a podium parking, which basically reduces the amount of steel and cement that is being used for the basement parking, and it also reduces the evacuation, carbon emitted through evacuation. Coming to reduction of embodied carbon, as we are using agrocrete blocks, we are carbon neutral. Here we are using a roof with carcrete, so we are again carbon neutral with carcrete. And here, for flooring, we are using vertified tiles, which emit less carbon than the other flooring options. Here, instead of our baseline was aluminum windows, but we are using UPVC windows with Saint Globin XT, which has less carbon content compared to other glass structures. The last would be the structure, as we are again using concrete, so this makes it 50. We could reduce it by 54.03%.
Resilience we have addressed in 4 methods, that is mitigation, preparedness, response and recovery. Unplanned development leads to climate change, which impacts on environment, buildings and occupants. Resilience against heat waves. According to IMAC acceptably range, the operative temperature should be 24.2 degrees Celsius to 30.2 degrees Celsius based on the simulation run on Design Builder. Design have achieved an operative temperature which ranges from 25.7 degrees Celsius to 30 degrees Celsius. The site receives an annual rainwater endowment of 29,200 cubic meter per year. By integrating storage water tanks, detention ponds, recharge pits, we have achieved an annual recharge storage of 30,342 cubic meter per year, with giving a total 19 days of complete water autonomy. We have inculcated various dedicated fire lifts and staircases with AI-based fire detectors and fire alarms and smoke detectors, which has addressed resilience against fire hazards. Strategically placed voids addresses the resilience against wind loads, and urban heat island effect has been taken care with the microclimate created within the site. As we have 75% of green cover. So overall, we have 20 days of complete water autonomy, energy. Since we are energy positive, we have 5,800 kilowatt hour excess of energy per day, and fire rated wall resists fire for 2 hours. Affordability from the baseline cost estimate to proposed cost estimate, we have a reduction of 14.5%. This has resulted in better affordability and low capital investment. Yet, energy efficient design and passive strategies and feature-rich designs have enhanced buyer values while keeping the pricing competitive. Our design is water positive with 18,750 liters of water excess per day. Using low flow fixtures, we have reduced energy bills by 34%. And for energy, we have used energy efficient equipments like LED bulbs, BLDC fans, which have reduced 41.7% in the water bills. So our project has achieved a triple net zero, and our design has focused on all the green building criteria, which making our project potential of making it a potential for GRIHA 5 rating and LEED Platinum building. The main indicators of our project are its location, its prime location opposite to Hope Farm Chandrasandra metro station, making it more connectivity to major IT hubs and amenities. Apart from that, we have smart, comfortable living, 75% of green cover, passive design strategies, and reduction in bills. Our project focuses on using low VOC natural materials, which results in cleaner air, better thermal comfort, soundproofing, promoting a health and quality of lifestyle. Further promoting community farming and organic farming. We promote organic and eco-friendly lifestyle. Various amenities like community gardens, green amphitheater, the clubhouse and gym and shared learning spaces lead to community connection, and power resilience with on-site generation minimizes blackout risk. Designed with empathy, engineered with purpose, and envisioned a future where water just doesn't flow, it is harvested, recycled, and respected. Communities just don't reside, they interact, regenerate, and grow together. Infrastructure doesn't just stand, it adapts, breathes, and coexists with nature. Mahindra Cascade is a commitment to that future.
With 9 seconds left, I would just like to add on that the water falling also gives a cascading effect that reflects on it.
Thank you, team. You did a great job. Let's hear the jury comments and take questions from them.
So, I loved your presentation. I think that, did you attend the webinar?
Yes, sir. Yes, sir.
I think it's the only team that probably followed the instructions that were provided in the webinar. Maybe one other team.
I was the one who asked the question that you made in the last year presentation.
Right. So and I also think that there was a lot of work that went into the presentation itself, the way it flowed and the transitions and all of that. And it was, to begin with, a very strong report. And it was a very good presentation. So
Thank you, sir.
I think that needs to be said. A few questions. At some point you said 2.1 years payback on the cost of construction, but then you're saying a 14.5 reduction in the cost. So I couldn't quite,
So that
figure
is
out what
only
was.
with respect to energy efficient methods and regeneration. So we've done
Okay.
a detailed thing only for how much additional cost because of those strategies it is.
Okay. I also wanted to look at, and I'm not going to make you repeat what I told you to repeat after the last entry, but I do want you to go back and look critically at what you are claiming, look at the LCAs of the materials, and find out why I'm saying what I'm saying.
Yes, sir.
Right? What is the digestive system of a cow, and how is it like an STP? I was like most intrigued by that. I was like, ये सवाल तो मैं पूछूंगा ही.
Yes, sir. So our industry partner is right here. So basically, cow's digestion works based on the anaerobic system. So it does not need energy. So how a cow's digestion works based on anaerobic form of bacteria, where even these stages are designed based on how cow digestion works. So first stage is primary sedimentation chamber, upflow baffled reactor chamber, attached growth biological filters, and plant bio. So this is how in stages of cow digestion also happens, and they mimic that in an STP.
Okay. Okay. You said the partner is here, so we'll talk. I'd be interested in understanding that. Yeah, I think why brown color for the facade? I was just because like the darker the color, the more you spend on like cooling the building, right? So I mean, it's a brand color or no? Maybe. Yeah. Oh, okay. Was that a deliberate color choice?
So basically we wanted to bring in more. So after talking to a lot of user groups there, people want to stay in more connection to the nature or use more natural materials or the colors in itself. So first of all, we thought we had a case study on total environment and how that bricks itself have impact on their mental health. So
Yeah, I think that's it for me.
Okay. Very nice presentation, as Alok already covered, and very nice prototype also. Cherry on top is that it's a working prototype. What is the water source here?
So we have a water tank
Oh, okay.
at the behind of the mod. Yes.
You have a submersible pump and.
Yes, sir.
Okay. Okay.
Water is collected and pumped back.
Yeah. Okay, I'll directly come to the elephant in the room.
Yes, sir.
Explain your flywheel and why is it generating energy?
So basically, that was our first question as well. Flywheel basically stores energy, it does not generate energy, right? So, on the other side. So basically this is a flywheel generator. It has a shaft. It has 22 tons, 22 number of wheels, each wheel weighing 22 tons. So let's take an example of a car. Let's lift a car and turn the wheel. So we're just going to give it a second of input, but it's going to rotate for 5 seconds, 6 seconds, let's say. It works on the same principle. We are working on the weight of the flywheel and the time. So let's say I give it 10 minutes input. It's going to go on for 25 minutes. I take out the input after 10 minutes, but it's still going to rotate for 20 minutes. So let's say in that 10 minutes input, I'm going to 500 RPM, and it's coming down. It's coming down to 250, 200 RPM. At 200 RPM, I'm giving it again input for 10 minutes. So again, it's going to go up and come down. So this is one innovation that Kama flywheel generators have come up with. They're working with government of Punjab and others. They're going to set up their plants there.
Tell me this, does it obey the law of physics?
It does not, sir. That's the whole debate of the company, that we are not obeying any laws of.
So then why are you accepting the claim if it's not obeying the law of physics? See, if I take an object, I push it.
Right.
So my input has stopped here.
Correct.
The object will keep moving for some time. Is the object generating energy?
No, generally it's not. Yeah.
It's just the kinetic energy is getting converted to potential energy again, and then the object stops.
Right, sir.
So over here, the initial energy input that you gave, the object is not going to generate energy intrinsically.
Okay.
Right? If it starts generating energy intrinsically, the only way is to convert the mass into energy, and then the nuclear.
That's one mechanism that even we had a doubt with, sir.
So then, see, I think throughout your reviews in D3,
we got
then
around
in
flywheel,
D4,
yes,
we
sir.
have also asked this. So why are you so adamant about this system? If there are questions on the fundamentals of it obeying the laws of physics, then why keep it? Why not go with something safer and something that's proven?
We did try out, sir, because even our rooftop area is very less.
Now, assume for a second that this works. Okay. So you have 22, how many rotors?
22 wheels, each wheel of 22 tons.
Okay. So first of all, do you think your land can take this much weight? This much density of weight? Assume that's also working. Now all of these are rotating. How much noise is this going to generate?
Apparently it's in they've tested it out, and it's below this one.
Is there any working prototype of this anywhere?
There is a working prototype. There is testing. It's been patented, and they have a research paper for it backed up, sir. Implementing
or implemented?
Implementing. They've signed an agreement.
So there is no physical system right now that we can look at, right?
A commercial system is not available right now.
It's not available.
Only a prototype is available.
How much noise does a fan make?
In decibels.
Not decibels, but it's like a very perceivable noise, right? You have to increase your TV volume when the fan is running.
Correct.
Now here you have like these large rotors all rotating at what, 1500 RPM?
500 RPM.
500 RPM. The fan does not rotate at 500 RPM. The fan's maximum RPM is somewhere around 300, 360. So with that, if the noise is so high, how much noise is your system
So
going to
we had that question as well. So we thought of having noise cancellation structures and stuff. But he told me, the company claims that it is in the here.
Surrounded by all green cover the trees. So that is again leading to resulting in noise reduction.
Even in design, we've addressed how to cut down on the noise.
Our main problem was a metro noise. So we have used insulation, so it will also add up to that down.
And how much area is this taking?
0.5 acres, sir, which is all placed in the master plan.
You already have that much space available?
Yes, sir. Yes, sir. We've incorporated that.
Okay. So now, after all this discussion, where do you stand? Are you still adamant on this idea, or you want to revisit this?
So, even after having discussions with our project partner, even they were curious about going in deeper. So until probably when the first prototype, that will be in, I think, 2-3 months set up. So we will know.
Can I jump in? MacD Burl is your also a partner,
yes,
right? they have anything? Did you run this by them?
Yes, sir, we did, and they were also curious because it was a new technology. Yes, sir, but they did not have any problems regarding sound or anything. So we.
No, sound is a secondary.
Yeah, physics is the
concern.
primary concern.
Okay.
Yeah, and now one other area you mentioned AI-based fire alarms somewhere. Why does a fire alarm have to be AI-based?
Okay, so. Yeah,
It's
so,
just a fire alarm, right? So AI, see,
just for optimization.
yeah, before ChatGPT, AI was a buzzword. After ChatGPT, AI got legitimacy, and there were actual applications that required AI that became enhanced by AI. But still, I think the tendency is there to put in AI wherever possible. So,
And with the growing future, AI is coming up. So.
but fire alarms में क्यों AI चाहिए?
So maybe again it can address different types of smoke. So for example, we have fire alarms in a restaurant also. So if a cook is making Chinese and the smoke comes out, the fire alarm will go on. So maybe AI based can detect. We're not sure, but we're trying.
So when you're not sure, don't put it in the report.
Sorry.
Well done. You've done really very well. And to take in this amount of grilling is not easy. And it kind of shows that it's not like cut paste, and you guys have really thought about things, and you've been able to kind of, understand and then put things forward. And plus your presentation was very good. You've presented very well. It shows that you guys have practiced, you've put in hard work, and you've kind of, done that past work of doing the presentation by yourself, speaking, all of that, and it shows. The hard work really shows, and I appreciate that effort that has gone behind.
Thank you, ma'am.
It's a very structured presentation. You've covered the points. It's clear. There's clarity. There is no hogwash in all of it, trying to, bring in stuff from everywhere and trying all 10 things at one go. Your design is practical, implementable. So congratulations for
Thank
that.
you, ma'am.
Couple of questions. And one of them is that, you've created those voids in between.
Yes, ma'am.
And typically by building bylaws, the minute you have one slab and another slab on top of it, that gets counted in FAR. So you've got columns, you have slab and the other slab. Whether you put the peripheral wall or not, the municipalities don't care. So is Mahindra happy to give away that amount of sellable FAR is my question.
Firstly, sir, ma'am, Sunita ma'am, after having discussions, they are very, their every strategy is for, for sustainability, they wouldn't mind. But secondly, coming to the comments that we had got on D4 on the same thing, one is giving the voids in, we have given voids in after every three floors levels, and the same thing can act as even refuge areas. So except just two voids, everything else are in the intervals of refuge areas.
Yeah, that is a suggestion which I had given, but refuge areas will not come every 3 floors. Huh? It's, I think, 15 meters or something. So it will probably be 4 or 4.5, 5 floors. So keeping that concept, you should probably minimize, reduce, and even then you will have airflow. Because this amount of foregoing FAR, I don't think MLDL is going to be happy doing. That is one. The second is that this eco STP and bioswales. We've recently heard in the news that the whole of Bangalore was flooded. What happens when all of this, that plantation area, bioswale area is completely flooded with water? What happens to your STP then? I mean, how does water purification happen?
Ma'am, firstly, flooding is little difficult in the site that we have proposed because we have given 13 recharge pits and strategies to...
Your recharge won't work when the subsoil water is already, it has water in it. It's already soaked with water.
Yes, ma'am, that's something we had to think about.
So think about it.
Yes,
the thing about giving such systems is always have a backup plan.
Okay, yes.
Okay, so you may not work that system, the more expensive automated or the machine it may not run. Like for example, you do have a solar system, you have a renewable energy system, but if you do it for an office building or a commercial building or residential, they will insist on a DG. So have that DG, do not operate it. Okay, so it's my suggestion to you. It is good to suggest these systems, right? But please do have a backup plan. Because in contingencies, this will not work. And imagine what is going to happen to your entire area. It's going to like smell like, you what. So just have that backup plan in mind and do not just depend on such systems. Yeah. Overall, very well done. Thank you very much.
Thank you so much.
Thank you, jury members. Thank you, Team Astitwa. Folks, that was our last presentation for the multifamily housing division. Our esteemed jury panel has shown immense dedication for assessing these entries, and I want to thank them. Thank you for all the thoughtful assessment and comments. Can we have a round of applause for the jury members? And I also want to congratulate the finalists. Applause for them also. As the jury coordinator for this division, I've had the opportunity to see the teams submit their deliverables. They have done some incredible work. Let us not forget that these teams have discovered a way to collaborate and do integrated design during the last 9 months. I think that itself deserves a round of applause. This evening, the jury members will meet and decide the winner and runner-up teams. Who do you think will it be? While we wait in anticipation, don't forget to head to our YouTube channel to vote for your favorite movie. You can vote till 5 p.m. today. We have an exhibition called the Climate Smart Innovation Exhibition, where you get to see innovative building products from the industry that address climate change. The exhibition is now open for you all. Please proceed to the multiplex zone, which is about 5 minutes from here. And for people who are online, stay tuned to your channel. At 6 p.m., watch the 10 exhibitors pitch their products in a bid to win the Climate Smart Innovation Award. Until then, have a great evening. So this now.